Let's start with a round of introduction. So hello everyone, my name is Samarth Narula. I have total 6 years of experience in IT industry and I'm currently working as a technical architect, and today I'm going to be your Spring Boot trainer. Now I would like you guys to introduce yourself. We can start in any order, like we can start with Michelle or Michael. Um, or maybe Nick, you can go first. Please introduce yourself. Guys, are you able to unmute yourself?
Yes, of course.
Okay. I thought that permission is missing. Hi, Tom. Tom, maybe you can introduce yourself and break the chain and pass on the mic to someone else in the crowd.
Yeah, certainly. Definitely really pleased to be here for the spring. And I've been studying with Samarth for a while now, and learned loads about Spring and cloud, and really looking forward to the session. So passing on to Michael.
Okay, maybe pass on to someone else.
Nick. Or actually, let's have a look. Mahesh. Yeah.
Mahesh, can you introduce yourself? I think he recently joined.
Yeah, I am newly fresher. Actually, I'm learning basic Spring frameworks like Spring Boot and microservices. Actually, I'm starting with Java. Yeah, I have a little bit idea about basic, but I'm not aware full. That's why I'm want to like learn more things in that Spring.
Okay, Mahesh, you can pass the mic to someone else from the list.
Yeah, is there any Divya Aurora? Like anyone can okay, but
Actually, she just mentioned she is not feeling well, so she'll introduce herself in the chat. Some
yeah,
guys have introduced in the chat.
Deepthi, Nick, anyone?
Okay, so that's fine. No worries, Nick. I think now enough participants have joined. No worries. I can start sharing my screen. Quick confirmation if you can see my screen.
Yeah, it's visible. Yeah.
Okay. Let me walk you through the agenda. Let's open the chat at the side. Okay. So this is the agenda for today's training. So we'll start with the introduction to Spring Boot. Then I'll explain you how to use DevTools and how it enables rapid application development. Then we'll see how we can do performance monitoring with actuators. Then we'll learn about profiling, how we can manage different environment specific properties by placing into environment specific property files. Then we'll learn how to create Pojo classes, or call it model design, in Spring Boot. Then you're going to learn about Lombok Framework and how it helps us to avoid a lot of boilerplate code. If I'm too fast, just let me know. I'll go a little slow. Next is the controller tier. Then we'll learn how to create controller classes. Then we'll learn how to create API documentation by using Spring Doc dependency. Then we'll learn some advanced concepts, like we'll implement builder design pattern using Lombok Annotation @builder. Then we'll learn about service classes, how we can create service classes. And the database that we are going to use for this course is embedded database H2. So we are going to learn how to use embedded database H2 for the POC, POD kind of projects, where we can quickly create the application and then change the database credentials to a final database, so that we don't have to do the cleanup while coding our application. Next is we are going to learn about what are entity classes and how to create entity classes. Then we are going to understand and implement JPA with Spring Boot. So we are going to create CRUD CRUD APIs, which will basically create an entity class or add a row into the database table, fetch a row from a database or fetch all the rows from database, update a certain row. So all those kind of CRUD operations. And then we're going to learn about Microstream. What is Microstream? And I'm going to provide you walkthrough of a Spring Boot Microstream integration project that I've built. So let's get started. Give me a moment. So I'm just reading through your messages. I wanted to have this introduction so that I can get a background about your experience. So I see there are some Java developers, and yeah, so some of you have basic idea about Spring Boot, Java 11, Spring Boot, 7 years in Java, Spring Boot, nice. .NET, C#, okay. So this is good. Okay. So welcome to this training. This training is funded by Microstream and JavaPro. Spring Boot Fundamentals. It is your path towards becoming a microservice architect. Durga Prasad, yes, this recording will be shared. Presentation won't be shared, but recording will be shared with you guys and the code will be shared. If you're attending the training, you'll get these things. All you have to do is just reach out to the JavaPro guys or from the mail ID that you have received the invite. If you don't get a reply from them, then you can reach out to me on LinkedIn and I'll help you basically get the recording from them. So we have few more questions from Michael. You're from Germany, right? So it's Michelle, right? Okay. Michelle, it is recording of this meetup. Yes, it will be available to you guys. Zoom meeting earlier this year. Recording of part 1 So Michelle, this is part 1 only. This is Spring Boot fundamentals. We also have on 22nd Saturday, which is another Saturday, training on Spring Boot advanced topic, and one more training on Spring Boot advanced 2 topic, which will be Spring security. Okay, so now that I've answered all the questions, let's proceed further. What are the prerequisites for this course? So you should have workable knowledge of core Java. Even if you don't have, it's fine. But it's good to have this because this is mandatory, kind of mandatory, but I'll try to make the explanation as simple as possible for you guys. Softwares that you would require is JDK 17 and Eclipse IDE greater than 2020 or 2009. So you can have this or greater than this. Good to have some basic idea about Maven. Even if you don't have Maven basic idea, that's fine. Just let me know. I'll explain you how we are using Maven for dependency management. So let's get started with module 1, Introduction to Spring Boot. So let's understand what is Spring Boot. So Spring is a framework. Boot means bootstrap. That means Spring Boot is a framework that allows us to bootstrap microservice applications which are easily deployable onto different cloud environments. So it's a framework and it makes easy to create microservices. So using Spring Boot framework, you can easily create multiple microservices and you can deploy these microservices onto different clouds. So some of the famous cloud providers in market, or you can say famous clouds in market, are AWS, GCP, and Azure. When you're working with Spring Boot, you will find that it's very easy to configure database configuration, performance monitoring, and other configurations in your Spring Boot application. Whereas when you're working with other frameworks, you'll find that it's very difficult to configure these things. But with Spring Boot, it's very easy to configure these things. Because Spring Boot has this thing like convention over over configuration, which is one of the characteristic of Spring Boot. We'll come to that. So why to learn Spring Boot framework? So if you learn Spring Boot framework, you can easily build microservice applications, and it's also a most popular enterprise application development framework in the market. So it will help you to get good jobs and do good in your current job. Also propose architectures in which involves a lot of microservices, and you can code those microservices very easily if you know Spring Boot framework. Because in this training, I'm going to teach you how to create APIs. You can create APIs, sell APIs online, And also you can create APIs for a lot of different things, like for a lot of front ends and different purposes. So Spring Boot helps you to write high performant, easily testable, clean, reusable, and maintainable code. And the applications built with Spring Boot are easily deployable on different clouds. Now let's understand the difference between microservice and monolithic service. So what is a monolithic service? In order to explain you monolithic service in short, you can imagine this is one microservice here. It has payment functionality and add to cart functionality. And this is your e-commerce application that you have. So this is your backend, which is having one maybe Spring Boot application, which has payment functionality and add to cart functionality. And this is your front-end application, which you have created using Angular or React. And from here, it's sending request to this microservice, which has these two APIs, maybe payment API and add to cart API. Now tell me one thing, what will happen if your backend application goes down? This application, which has this payment functionality and add to cart functionality, goes down, or if it crashes, what will happen in this case? In this case, your entire application will go down. Your customers won't be able to add items to the cart, neither will they able to make payment for the payment for the items in the cart. So it will be a complete downtime. Whereas in a microservice architecture, what we do is we split the two functionalities, payment functionality and add to cart functionality, into two different microservices. So in this case, we have one microservice with payment API, another microservice with add to cart API. Now, even if my let's say my payment application is down, my customers can still add the new items to the cart, and they can try the payment later on once this applications come back up. So so you can have some functionality like if for some reason customer payment has failed, you can send a message, please try again in 5 times, there is load on the server, something of that sort. So in this way, you'll never have complete downtime. And this has given birth to the microservice architecture. So there are multiple other reasons, but this is one of the core reasons. Now let's understand the characteristics of Spring Boot framework. So Spring Boot is an opinionated framework because it has some conventions that you need to follow, and it believes that you should have easy to do configurations. So we can say there are conventions over configurations. That's why some developers have opinions. Why do we have conventions when we have lesser configurations? But that is how the framework is designed. Next very good characteristic of Spring Boot is you start with something. Since we have Spring Initializer, which allows us to bootstrap our skeleton Spring Boot applications, which I'll show you as part of the next topic. So you start with something and you can tweak it always based on your requirement. Also, these Spring Boot applications are standalone applications. If you add the web dependency in your Spring Boot project, you get the embedded Tomcat server. So because of that, your Spring Boot application is also a standalone application. Also, the applications built using Spring Boot framework are production ready because you can easily build the jar of that application and deploy that jar onto your cloud environment, maybe on EC2 machine or directly to EKS, whichever place you prefer. Basically for EKS, you'll have to write the Docker file, write the Kubernetes deployment service and all those things. Okay, coming back to this one, next topic, how Spring Boot is better than Initial Spring Framework. So Initial Spring Framework was a huge framework. It had multiple setup steps. We're not going to learn the Initial Spring Framework in today's training. We're going to learn Spring Boot Framework and directly what matters, which is how to create APIs. So Initial Spring Framework was huge framework. It had multiple setup steps, multiple configuration steps. Handling dependency management was a difficult task when the project grows. And what Spring Boot has done is it has abstracted out all these complexities and handled at a framework level so that a developer can focus on the business logic. Now let's start with the practicals. All this training, all my trainings are 95% practicals, 5% theory. So we are starting with this practical introduction to Spring Initializer and creating a project with Spring Initializer. I'll show you how to create a skeleton Spring Boot project, how to download it, and I'll just show you the steps how to import the project. But I've already imported a complete project, which I'm going to use for today's training. But I would advise you should follow up with this training, do the steps that I'm showing you, and let me know if you have any issues. Because I want this training to be completely interactive and you guys to take the most out of this opportunity. So let's see how to create a skeleton Spring Boot project with Spring Initializer, how to set up Eclipse Workspace, importing the generated skeleton Spring Boot project in Eclipse IDE, what is the step, and some easy steps for fixing common build issues. So let's get started. Let's go to Spring Initializer. So this is the Spring Initializer. It's the web application. The very first thing you have to select is a project. So I'll select Maven project, and please use Maven project for this training. Language is Java. Latest stable version is 3.1.3. You can use this, or I'm using this version here, 3.0 point something, 3.0.2. Next is your group ID. You can give the appropriate group ID. So as part of this application, what we are going to do is we are going to build a bookstore application. So you can name it com.bookstore or com.example. Next is the artifact ID, name it Spring Boot Bookstore, name also the same. And description, you can give learning Spring Boot, and package name and group name should be same. Ensure one thing, that this two should be same. If I write here something, you see how it appears. So once you've made all these changes, then give your package name in the end. Just copy your group ID from here like this and paste it here, because your group ID and your package name should be same. Packaging, select jar, and Java version select 17. One thing here, with Spring Boot version 3 onwards, you have to mandatorily choose Java 17. Even if you use 8, when you download the project, you'll see that it is referring to Java 17 only. Now add dependencies. So for this project, you will have to add web dependency, then DevTools dependency, Lombok dependency for cutting the boilerplate, JPA, then you need to add H2. Yeah, so all these dependencies. Spring Doc is not available here, so you need to add it from, I'll provide in the chat, Spring Doc dependency, and yes, also actuator. So go here, type actuator, add Spring Boot actuator. And this dependency, yeah, Spring Doc Open API is not available. So let me provide this over chat. So I've provided over chat. You can copy it from here and add it. Also, you need to add which APA in the latest version. You need to add this validation, Hibernate validator, Jakarta validation API. These are just some dependencies which should have come ideally from the JPA one, but they don't. So you need to add it separately. I've provided these dependencies in the chat. Please copy paste these. Okay, so coming back here, just copy and keep it for now. Once you have selected all your dependencies, if you want to see how the project structure would look, you can click on this explore, which I just did, and you can see the POM file here. This is your Spring Boot parent version 3.1.3, your group ID, your artifact ID, your version, the name, the description, the properties. You see it's selecting Java 17. And you need to select Java 17. Even if you select 8, you'll see 17 here because it's mandatory from Spring Boot 3 onwards. Next is you see actuator, JPA, web, all the dependencies here, and DevTools, H2, Lombok, and Spring Test dependency. Next is the source. So we don't need to go from here. I'll provide you the walkthrough. Once you have selected all these things, just click on generate, and it will download the zip file. Unzip this file anywhere you like, and once you've unzipped, just right click here like this and go to import. Type here existing Maven projects, click on next, select the directory, the directory of your unzipped file, and go inside your folder. It will automatically detect the POM file. So once it detects the POM file, it will appear here. Click on finish. Once you have done this much, just let me know in the chat that done. Then I'll tell you the next steps. Sure, I can show the dependencies. Also, what you guys can do is I'll give you my GitHub repo of my last training. From there, you can copy paste all the dependencies. But don't copy paste the entire code, because I just observed one thing today, that one of the method was breaking and I just fixed it. So here 3.0.4. So refer to this POM file here, copy the dependencies from here. Once everyone is done, please write done in the chat. That then I'll come to know, okay, you all guys have generated the project, imported the project, and then I'll tell you how to fix the issues. Take 5 more minutes or 3 more minutes. But once you're done, please update me in the chat. Let me know. Just write done. That way I'll know, okay, you have imported the project. Okay, good, Durga. Michael, I'm not sure. So you'll have to check with the JavaPro guys on this, whether you'll get the certificate or not for this training. It's more of for real knowledge sharing. Mohammed, that's the answer for you. Sorry. Spring Doc dependency again. Michael, I've shared the dependencies and I've also shared my GitHub link of this repo. It's a public repo. So you can go to POM file and from here you can copy all those dependencies which I've shared in the chat. So copy the missing dependencies like Spring Doc, Open API, validation, Hibernate validator, Jakarta validation API. Okay, Mohammed, I'll speak little, I'll keep the pace of the training little slow so that there is no issue. Okay, so is everyone done now setting up the Eclipse? Perfect. Also, what I would advise you guys is you can directly clone this project and keep. I'll share the repo once again. Just clone this project and keep with you. If it's not compiling, don't worry. I'll tell you why it's not compiling and how you can compile it. So I'm sharing the repo in the chat now. So do import this project and keep. We are going to refer to this project. Only this version is which I've shared is a slight later version. So here I'm using 0.2. I've shared is 0.4. So you can clone that. Let's proceed further. Once you have cloned this project, which I've shared with you, it's the same project. Now you might find some compilation issues with your Lombok annotations, which are over here. So how do you fix these Lombok annotations? So in order to fix it, you need to search your Lombok jar in your local, double click and run that jar. So let's see where it is. Lombok. Here it is. So whatever version it is, don't worry about it. Just go to this path, and inside this path .m2 repository org project Lombok. .m2 users .m2 repository org project Lombok, and whichever version you have, locate this jar and double click this jar and wait for a while for this to launch up. It will scan your drives for ID installations. If it's not able to find, you can manually specify the path of your eclipse.exe file. Once it finds that, click on this install and update. I'll not do this because I've already linked my Eclipse with my Lombok jar. This is needed for Eclipse IDEs. So if you guys are using Eclipse IDEs, that is what I recommend for this training. Then you need to do this step. If you're using IntelliJ, you need to go to IntelliJ Marketplace and install the Lombok plugin from the IntelliJ Marketplace. Once it finds it, it will be ticked here. Click on install and update and click on quit installer after the install and update. To confirm that your Lombok has been linked successfully to your Eclipse, what you can do is, first of all, once you've done this, click on this project, click on this clean, and clean all projects clean. And after this, in order to ensure that your Lombok jar is successfully linked, go to About Eclipse IDE. So this kind of a prompt will load up, and here you will see Lombok, your version is installed. If you're seeing this, that means your Lombok jar is successfully linked with your Eclipse IDE. If you're not seeing this, that means you have not selected your correct Eclipse IDE exe file in the previous step where I showed you double click this exe file, this jar, basically double click this jar. So you need to specify the location manually of your Eclipse IDE exe file and do that install and then quit installer thing. Also, you need to restart your Eclipse IDE once you have linked your Lombok jar with your Eclipse IDE. Once it's successfully linked, I would advise just once restart your Eclipse IDE, close it and open it again. So if you guys are done with this step, just let me know. Write done in the chat. Is everyone done with this step? Take 2 more minutes. Just do these steps. Once we are done with the setup, the entire training will be very smooth and fast. I mean, the pace will be good because I understand in next 3.5 hours, we need to cover a lot. Michael, you can work with both, but your own generated project was a practice, like how to use Spring Initializer. But I would say use this cloned project because it has all the code that I'm going to provide you walkthrough. So parallelly, you can comment, uncomment things and learn during your training also. Yes, you can use even later version also, Michael. Like latest is something 3.1.4. You can update this project version. I don't think anything will break. I had migrated this version from 2 to 3, so I had to do massive changes. Like first of all, I had to figure out, okay, this latest version, like 3 onwards, it doesn't work with JDK 8, so I had to switch to JDK 17. And then all these dependencies I had to add, like figure out one by one and add these things for migrating the project. The Jakarta validation, Hibernate validator, and this Spring Boot starter validator. Also, I had to switch from Swagger Fox dependency for API documentation to Spring Doc dependency because Swagger Fox has conflicting dependencies with Spring Boot version 3 onwards. So guys, from this training, I'll be walking you through this project. So take this project as a skeleton project for building your office projects or your product. If you're building any product of your own product, you can use this as a skeleton project. It will have all the things you would need for building your APIs, all the example code. All right, let's go to the next step. I believe everyone is done so far. So everyone has imported this project. Okay. Now let's understand how Spring Boot application runs. So as part of this hands-on, I'll provide you understanding of the project structure, how to run the application in run mode, how to run the application in debug mode. We'll understand how Spring Boot application runs and a quick fix which can be used for common port already in use issue. So you must have seen this issue a lot of times. Don't restart your laptop because of this issue. I'll show you a simple shortcut fix for this. Okay, so let's first understand the structure of the project. So this is your project. This is your main directory. This is your resource directory. This is your POM file, and you can have a README file also. So in the POM file, we understand the structure of the POM file very well. This is the Spring Boot parent. Here we can see the parent version 3.0.2. This is the group ID. This is your artifact ID, Spring Boot Bookstore design, and this is your name. So when you build the jar, it will get this name dash this version. Your description, your JDK version in the properties tag. In dependencies, what we do is if we add actuator here, it will go to the Maven repo and download the actuator jar and bring it for us and place in our .m2 repository folder. So you can see that all these things are getting downloaded and it's getting placed here in our local and being referenced from our local .m2 folder, whichever subpath over here in the project. This is what Maven does. So those of you who are new to Maven, Maven is nothing, just a dependency manager. Like you can add these tags and you can just add these tags here in this dependency section, a new dependency, and it will automatically, when you save this file, download the jar and place in your .m2 folder and refer from there. So if you want to search a jar online, so how do we do that, right? So you will be thinking, Samarth, if I want to search a new jar, how do I do it? So just type, let's say for Spring Doc, you can just type Spring Doc Maven. Just type like this on Google. And the first link you will get is the dependency link. And you can open the dependency link, click on the latest version and click here, copy this and paste in your Spring Boot this dependencies part. Just paste it here. That's it. That's all you have to do for a new dependency. So is what is Maven? Is this part clear to everyone? Those of you who are very new to like Maven part. CCS12, I'm not using STS because it doesn't works with DevTools and Lombok really well. For IntelliJ IDEA, I would say community version also does. It's not mandatory that you use ultimate version. I've worked on community version and I've not find any problems. So there's a question from Mohammed. Is there any specific setup parameters to install for Eclipse editor concerning the SDK JVM add-ons? Is there any specific setup parameters to install IntelliJ? So there are no specific parameters. You can simply search Eclipse download on Google and just download the latest version of Eclipse. Okay, please zoom the editor. Okay, so is the font size visible now? The more the better. Yes, that's right. Okay. A bit more. Okay. If we go too much, it doesn't make sense to have a big screen because then you cannot see the code, right? We'll keep switching the font size in between. Sure, I can summarize. So I'll summarize once. Let me finish this hands-on, then I'll summarize it. So I've given you the project. Okay, we are at project structure. So this is the POM file. It has the parent, it has the group ID, artifact ID, version, name, description, properties, and in properties, we are telling that we are using JDK 17. We have these dependencies. In this dependencies, we are mentioning our dependency, like we are using actuator dependency, we are using JPA dependency, web dependency, DevTools dependency, H2 dependency, Lombok, and so on. Okay, so below is the part which you don't need to care much about. It's automatically generated from the Spring initializer to handle the Lombok and to exclude whatever needs to be excluded. So going to the next part, how to run the application in run mode. Okay, so this is the structure. So this is the main directory, and in main directory we have the base package. This is called as base package com.example. In Spring Boot, if you see in all Spring Boot applications, we have this kind of a structure. We have the base package, and if you want to create any other package, this is how you name the package. It's a convention which you have to follow. You write base package name, which is com.example, and dot your package name. For example, here we can see controller. Similarly, if I want to build another package, how will I build that? Again, I'll take the base package name, which is com.example, and I'll write my package name, which is .entity. So this is how you create package names. All the names should be like this, like base package name, your package name. So it should have this base package name and then whatever you want to add. So it's a convention that we need to follow because Spring Boot application has a component scan which starts from the base package and scans all the sub packages in the base package. So if you don't follow these conventions, if you just give random package naming, your Spring Boot application might not just start properly. So that's why there are some opinions. One of the characteristic of Spring Boot that it has some conventions over configurations which we need to follow. Okay, so this is the base package and this is the main file. Now you can ignore this part for now. So this is our main file. This has the main method, and this is the line which gets executed and a Spring Boot application starts. Now different ways of running the application are we can simply right click, run as Java application. Don't worry about this code. I'll explain you this as we go through different topics. So you can see our Spring Boot application is starting. And okay, it's taking a while. So our Spring Boot application has started. It's running on port 8080. We can see here. Now, this is one way to start. Like you can go open the main file, right click, run as this, or from the left hand side also you can do right click, run as Java application. Now, if you want to start your application in debug mode, instead of run as, you go to debug as and you select Java application to start your application in debug mode. This will start your application in debug mode. Now, if you're starting your application in debug mode, you might see a silent exception if you have not done the settings that I'm going to show you. So the setting is, you go to Window, Preference. In the preference, you type here debug and you search this debug by typing here debug. Once you come to debug, uncheck this box, suspend execution on uncaught exceptions, and click on apply and close. If you don't do this, every time your application gets restarted, when your application is running in debug mode, what will happen is you'll see a prompt saying silent exception and it will just irritate you. So just to get rid of that, it's your Eclipse IDE issue. Just do the settings which I have shown. Also, if you want your Eclipse to point to the correct version, go to preference, type here JDK, go to installed JREs, ensure you're seeing JDK 17 here. So locate the path of JDK 17 in your laptop and just add this over here. If you're seeing 8 or something old, you can either uncheck this, uncheck that and add 17 and check that, or you can just simply select and remove it and add the latest one. So when you click on this add, select standard VM, next, and give the directory path of your JDK. Like in my case, it is in, I think, program files Java. Yes, and then the version. This is how you'll see, and click on finish. I already have it, so I'm seeing this error, JRE name already in use, because I already have this. You don't need to set this really, but if you want, you can just select like this and click apply and close, but it's not mandatory because you can see by just selecting this also, it's able to get the libraries. So this is how we start the application in run mode, debug mode. These are the settings that we need to do. And for Lombok also, I've shown you the settings. And if you have any doubts, you can ask me again. I'll help you with the Lombok setup. So Lombok setup that I've shown you is only a first time setup. Once your Lombok is linked with your Eclipse IDE, you don't need to do that setup again. And how do you ensure it's linked with your Eclipse IDE? You go to help, about Eclipse IDE, and here you should see Lombok part. If you're seeing this and still getting some error with Lombok, what I would advise you is simply restart your Eclipse IDE and it will fix it. Okay, so next part is, we have seen this, we have seen this, we have seen this, we have seen understanding about how Spring Boot application runs. We have also understood this. We understand how component scan works and why we need to name our packages like this. Next is, let's understand quick fix, which is a common issue, like port already in use issue. So this generally happens in Windows laptops. So if you right click this, run this, let's say the application is now running. Let it start. Let it consume the 8080 port. Okay, one more thing, guys, if you want to connect with me, I also have courses on Udemy, Coursera, and different platforms. If you want to connect with me or get my courses which are on different platforms, I'm sending you a consolidated message in the chat with all the things. So you can keep this handy if you find this today's training, which we are conducting, useful, and if you would like to reach out to me for any further collaboration. Okay. All right. So next part is this. Yes. So now our Spring Boot application is running and it's already consuming our port 8080. Now what happens if another process or another Spring Boot application tries to run on port 8080? So let's say I'm just starting this application again. So it's already running in background, but I'm trying to create another instance of this application on my laptop, which will again try to run on 8080. So you see, this is the common issue which you will see. Like if by any chance your Spring Boot application is running in the background and it didn't got terminate from your Eclipse, so you'll see this identify and stop the process that's listening on port 8080 or configure this application to listen on another port. So port 8080 was already in use. Now, if you want to start another instance of this application, how you can do it is, first of all, right now we can just terminate this and do, but if you're trying to do it, because I have DevTools, so if I do this also, it will just terminate my old application and start a new one. But this is the property to change the port number of your application, server.port and port number. No, so now if I start this application, it will run on port 8081 instead of 8080. Let me quickly demo this. Oh, my bad. Some typo here. Thanks. Okay, so let DevTools restart. So DevTools has not properly restarted, it seems. Let me start the application again. So generally some configuration changes are not reflected very well. So some configuration changes are not reflected very well by DevTools. And if you want them to reflect, you have to manually stop and start. So now you see application is running on the correct port, which is 8081. Now, if you want to run this application on a different port, maybe 8082, you can just change it like this and save the files. So since I have DevTools, I don't need to manually stop and start the application. And what is DevTools? DevTools is nothing but this one simple dependency that I've added in my POM file. This is the dependency which is automatically restarting my application as soon as I change anything and I save the file. Let's say I add a new line. It's a change, right? It's a change in this file. Whenever there's a change in the file, you'll see this asterisk symbol here. And whenever you save the file, this asterisk symbol will disappear and the DevTools will restart the application for you. So this is what DevTools does. Now you see our application is running on port 8082. Let's get rid of this. Let's bring it back to the default port 8080. All right, so this is the first hands-on. So as part of this hands-on, you have learned about the structure of the generated skeleton Spring Boot project. Basically, we have this complete project here. So I've explained you the holistic structure of the Spring Boot project. We have seen the procedure for running the application in run mode and debug mode. We now know that Spring Boot application has an embedded Tomcat server. Okay, let me show this part. So since our application is running, so it's running, you see your Tomcat started on port. So our application has an embedded Tomcat server. This embedded Tomcat server is coming from this web dependency. If you don't add this, embedded Tomcat server won't come. So it's coming from this dependency. We know this now. And our application runs inside that embedded Tomcat server. So our Spring Boot application is automatically deployed inside that embedded Tomcat server. And last, we have learned about the configuration required for changing the port, which is this property, which we have seen, server.port and the new port name. This changes the default port name to whichever port you set it to. And our application gets hosted locally onto that port. And you can use that property server.port for quickly resolving port already in use issue. Okay, so next is DevTools. Let me again, I just gave you a little bit idea about DevTools, I know, but let me just give you a good demo of DevTools. So Venkat has a question. When is the situation where one has to kill the PID or it is not necessary? It is necessary in a way if you want to free and use 8080 or the same port. Venkat, I can show you the commands. I'll just have to search the command. That's a separate lab. How to basically free the port For now, I'll just share the commands with you guys and keep if you want to terminate your application. Spring Boot. I think it's my Windows, some Windows. Yeah, Windows OS thing. Yeah. So these are the commands. This is the command for Mac. This is the command for Windows. I'm sharing these commands. So whichever user you are, you can use these commands. And using this command, you can basically, using this command, give your port number on Windows laptop and search your PID. Once you find your PID, try to kill your PID using this command. If this doesn't work, try this command. Any one of the command will work. Okay, I'm sharing these commands over chat. So this generally comes handy. Let's say for some reason you don't want to use port 8081 because you will have to make a lot of code changes in that case, because let's say any other microservice that you are using or coding with is referring to the port 8080. So you can do like this. Okay, this I'm going to demo. Don't worry. We'll come to this part. Okay, let's come to the hands-on. Let's understand DevTools. Let's understand DevTools in a way when we don't have DevTools. What happens when we don't have DevTools? So let's say we are not using DevTools. Okay, so let's say we are not using DevTools. What then? Let's say now we don't have DevTools. Let's see what is the error that we are getting. No error. Okay, so let's start the application. Let's go to the main file. This is the main class, and in this main class we have the main method. Here I'm also implementing command line runner, and from this command line runner interface I'm overriding the run method, and in this run method I'll add something now once the application starts. So everything starts with hello world. So let's write hello world. So now that my application has started, now if I save this file, will it print hello world? You see, it's not printing. You know why it's not printing? Because my application is not automatically restarting. So when you have DevTools, your application will auto restart whenever you save any file. When you don't have DevTools, you'll see that if you want this change to reflect, if you want this to get logged in your console, you need to stop your application and restart your application. Now you see hello world is getting printed. So if you don't want to do this again and again for every change, stop, start, if you don't want to waste your time with that, so for your development purpose in your dev environment or in your local environment, basically, not dev, local environment, you can just add this DevTools dependency and keep. Even if you push it to production, it's not going to break anything. So it doesn't matter. It will be just unnecessary jar file which gets downloaded to your production server. Now that we have added this DevTools dependency, and now when we start the application, first of all, obviously we have this already, so it will get printed. But I'll show you what other benefit we'll get now that we have added the DevTools dependency. I'll show you the use of DevTools dependency. So let's say here I see hello world, but I also want to say DevTools. Let's say I want to write here DevTools. Now this file is not yet saved. Now once I press Control S or Command S, depending upon your OS, it will save this file. And once it saves this file, now you can see my application got restarted in the background. It's still restarting. Okay. And once it's restarted, we can see that it's getting printed. So Since we have added this DevTools dependency here, we don't need to manually stop and start the application for every code change that we do in our application. Is DevTools clear to everyone? If it's clear, you can write clear in the chat and I'll proceed to the next hands-on. Perfect. Okay, before we go to this hands-on, let's take a 5 minutes quick break, and then we'll start with this hands-on, understanding actuator and its health endpoint. Let's catch up again in 5 minutes. I hope everyone is back from the break. Okay, let's start the next hands-on. Understanding actuators and its health endpoint. Let's see which is the actuator dependency. So how to inject actuator dependency? You just need to add actuator dependency, which we've already done here. So we already have the actuator dependency. Next is understanding health endpoint and then enabling the default, the detailed health endpoint, then practical industry scenario where you should use actuator health endpoint. Okay, once you add the dependency, once you add the actuator dependency, you automatically get the actuator health endpoint. So it's by default there. Now, if you want to see which all actuator endpoints you have, you just need to copy this, go to your browser. So our application is running on port 8080. Let's open a new tab. Let's write here localhost :8080/actuator. So this is the actuator base URL, and here we can see all the actuator endpoints. So if you want to open the health endpoint, you can simply copy paste this link onto a new tab. And this is the response of this health endpoint. It is telling that our application is up. So status up means our application is up and running. If there is any problem with our application, we'll see a different status than up. Now, if we want to enable detailed health endpoint, in that case, first of all, we need to uncomment this dependency, which is management.endpoints.web.exposure include, and we need to add the health dependency. Actually, we don't really need this for now. Let's comment that out again. For detailed health endpoint, we just need to add this dependency. So I've added the comment here. Configuration of actuator detailed health endpoint, just uncomment this dependency, this property, uncomment this property, management.endpoint.health.show-details equal to always. Once you write this line in your property file, and after writing this file, if you refresh your health endpoint, you'll see a detailed response. Now it's telling us the status of our application and various components of our application. So this application is running on my laptop, and it's using the embedded database H2, which you'll learn eventually as part of this course. So it's telling the status of the H2 database, that the H2 database is up. It's also telling the disk space of the application, disk space of my laptop. It's saying that my hard disk is working properly, and the total details, like this details, which is total bytes, this many bytes I have in my hard disk, this is free, and this is the threshold, some values. And the ping status of the application is up. So this is about the detailed health endpoint. So when do you use this? So let's say you've created a Spring Boot application with various APIs, and you are deploying this application onto cloud. Now, once you deploy the application on the cloud, you'll not go to your cloud server and log in and check the status of your application, right? If you have access from your laptop, so what you'll do is you'll hit your cloud API, cloud endpoint, health endpoint, actuator health endpoint, and that will tell you the status of your application. So you don't need to log into your cloud console, connect to your EC2 machine or to your compute, whichever cloud you're using, and you don't need to basically just go inside and check the things. You can just hit this endpoint and get the details. So it's useful when you're deploying your application onto cloud. If you're deploying this application onto any cloud, this actuator is a must for a Spring Boot application. Okay, let's go to the next one. Is this clear to everyone? Actuator health endpoint? Perfect. Let's see the next one, info endpoint. So how we have health endpoint, similarly, we have another endpoint, which is info endpoint. Guys, what I'll do is in today's training, instead of focusing on completing everything which is part of the curriculum, in the time we have, I'll try to teach you maximum from here, and definitely in after next 30 minutes, wherever we are in the above content, will halt, and I'll teach you, like, once we reach till this point, let's say this point, after this point, I'll teach you first the Microstream and then we'll continue with the H2 because this training has been funded by Microstream and JavaPro guys. So we'll learn this part and then we'll continue with this. So instead of focusing on finishing everything, what I'll do is I'll focus on basically ensure that you learn whichever point you have learned. Okay, let's go to the info endpoint. So in order to enable the info endpoint, as you can see, first of all, it's by default not enabled. So by default, we don't see info endpoint here. So in order to enable the info endpoint, we need to add this property and this property. Now info endpoint will be visible. So let's wait. All right, let's refresh this now. And now we can see we are seeing the info endpoint. Now if we trigger the info endpoint, we are seeing an empty response because we have not configured any information to be returned. In order to configure the information to be returned, these are the properties. I've added the comment here, just uncomment this. And this is the way you write the properties. All the property names start from info dot whatever you want to write, like project name, team, instructor, environment. Once you write this and you go back to your info endpoint, now if you refresh your info endpoint, whatever information you have written there will appear like this over here. So this way, you can provide information about your application by using actuator info endpoint. Now it's useful when you have multiple applications in your team or in your organization, and the multiple different microservices, or you can say applications, are built by different teams in the company, and these microservices are communicating with each other, and you would like to reach out to a team which has created a certain microservice, and all the teams, let's say, are using Spring Boot and actuator. So you can hit the info endpoint and get the team details and reach out to that team if you want to update a certain API or request a new API from that team. So this is one practical use case where you can use actuator info endpoint. Is info endpoint clear to everyone? If you have any doubts, you can ask your doubts. Okay, perfect. Let's go to the matrices endpoint. So similar to info endpoint, we also have the matrices endpoint, and we have enabled the matrices endpoint also by writing matrices here. So to this property, whichever endpoints you want to write or enable, just comma separate and write the endpoint name, like health endpoint, info endpoint, matrices endpoint. There are multiple other endpoints. Okay, now let's see the matrices endpoint first. So now that we have the matrices endpoint, let's open this in a new tab, and this is how it loads up. Now if you want to see the total disk free space that I have, so we'll just select this, copy this, modify this URL like this, and hit enter. Now this will return me the disk space. So this is how you can get information about various matrices of our application or of the server on which our application is running. Now if you want to see the JVM threads which are live, so just copy this part, jvm.threads.live, modify your URL like this, and you'll see the information about current number of live threads, including both daemon and non-daemon threads, like 25 threads. So this is how you can use the matrices endpoint. So this is very useful if you want to download thread dump or heap dump of your application and use the tools which are available for analyzing your heap dump and thread dump for performance optimization of your application, or for various other purposes, maybe for security purpose also, if you want to see any keys getting leaked or something. Okay, so this is a must. You can also build dashboards by fetching these matrices of your application. Next is if you want to change the base URL to a custom URL. Right now, this is the base URL that we are referring here. So we want to change the base URL to a custom URL like this, like app check instead of actuator. How can we do this? So there's a property for that, which is this property. If you add this property and you provide your custom URL, your base URL will be changed to custom URL. Now, let me copy this and keep, because the base URL will no longer work. Now this will not work anymore because we have changed it to this one. Now this is the new URL. Do you suggest Spring Boot admin to have GUI for actuator? Okay, GUI. So for UI, so there is no specific UI. Like if you want a UI, you can use Grafana and build some UI also by fetching the matrices, or use some other, the ready-made libraries like Prometheus, Grafana, these things for building. Like generally, this matrices endpoint is for simple monitoring and the other purposes, like just download the heap dump, thread dump, and do this. Let me show you how to hit that, since we are talking about that. In order to enable all the actuator endpoints, just write star here instead of the individual endpoint names. This will basically show you all the actuator endpoints. Now, I don't recommend this for your production. It's not safe. You should only enable what you need. So these are all the endpoints. If I click this, it will download the heap dump. If we click this here, we can see the thread dump. So we can copy paste or download these things and use these things. Like use the tools which are available, ready-made tools, which are paid tools for analyzing the thread dump, heap dump of our application. One free tool for analyzing heap dump which is an online tool, if your company allows to use such a tool, so you can use, which is Heap Hero. So this is a ready-made tool. You can directly download the thread dump. Yeah, this will not work. App check. You can download the thread heap dump and load the heap dump over here and analyze it. I'm not going to demo this because it's not part of this, but you can try it out later on. Okay, so we are done with module 3. Next is module 4, profiling. Are there any freshers in this training? If there are any freshers, I'll explain this part. If there are no freshers, we'll directly move to the practical part. Guys, please speak up. Are there any freshers? If no freshers, let's move to the next topic. Okay, great. Let's move to the next topic, profiling. So profiling is done for placing environment-specific properties into environment-specific property files. So what is profiling? Profiling enables us to separate the cross-cutting concern logic of externalizing configuration into environment-specific property files. Let's see this in action. Right now, all the properties that we were adding to this application.properties. So this is our local properties file. So if you want to have development environment specific properties, we can place the development specific environment properties in the application-dev.properties file. And here we can see for my dev environment, I would like this application to run on a different port, which is 8081. For my local environment, I would like this application to run on the default port, which is port 8080. For my production, I would like this application to run on port 8084. For test environment, I would like it to run on 8082. For UAT, 8083. So this way we can have separated properties. Now, how do I refer to dev properties? So if I want to start my application using dev properties, like if I select dev properties and start my application will then start on port 8081. If you want to select dev properties, all you need to do is use this property. It's a very important property, spring.profiles.active, and just give whatever is after this dash, like dev. Now, once I save this, my application will read properties from this file and will override whatever properties are coming from this file, from the application.property file. So properties from application.property file will be overridden by the same properties which are available in application-dev.property file. Now, if we scroll down, we'll see that our application is running on dev port, which is 8081. Now, if we want to start our application on as per production port, so I'll write here prod. Once I write here prod, in the prod properties, I've configured the application to run on port 8084. So application should now run on port 8084. Let's scroll down and see. So we can see application is running on port 8084. So this is how we can place our environment specific properties into environment specific property files. This is the convention. All you need to do is write application dash whatever name you want to give, be it dev, prod, UAT, prod like, whatever environments you have. There is no limitation. You can create as many property files as you like and refer to them. So here I'm referring to prod right now. So that's about properties. We have seen how the port number changes as per the active profile that we set, and this profile is referring to the active environment. Okay, so Mohammed, okay, so there is one fresher. So Mohammed, in our office environments, we generally have different environments, like we have development environment. Once we build the code locally, we push the code, we deploy the code into dev environment. We test the application there. Once the application is running properly in dev, we then deploy our application in test environment, and the QA guys basically test our application in the test environment. Once they give their go ahead, then we deploy our application in staging, or call it UAT environment. If you're working in a product company, you'll see staging environment. If you're working in a, like the name will be staging environment. If you're working in a service based company, you'll see the name as user acceptance testing environment, UAT environment. Now here the product owner of your application or your manager will test your application, and once it's tested here, then the application is deployed in the production environment. This is the last environment where new business functionalities are deployed for end users. Once it's deployed here, it will be available for your clients or customers. All right. So is profiling clear to everyone? Okay, so coming to the part where someone had asked the question, if I want to free the port, how do I do this? So let's say now my application is already running on port 8084. Now I want to free this port. Okay, I want to get rid and I want to free this port. So very first thing I'll do is I'll open my command prompt. I want to free my port 8084. I'll go to my keep, copy the command from here. Make it 8084. Find the PID. So PID is 4696. Now I'll copy this command. Paste it here. Change the PID. So PID is 4696. This will free my port. So see success. The process with PID 8696, which was linked with my port number 8084, has been terminated. Now if I go back to my Eclipse, you'll see the application is already terminated. It's already terminated. So it got terminated because I searched the corresponding process ID and I used this task kill command and I killed it. So I've shared these commands before. I'll share it again. So on Windows, we do like this. On Mac, the command is below. And then once you find the PID on Mac, you can use kill, same thing, kill and the PID. Yes, Michael. So I've set the active profile as prod. Spring.profiles.active equal to prod. This is the last setting which I've kept so far. So Venkat, the use case of profiling is you can place your environment specific properties into environment specific property files. For example, if you have a different information that you want to provide for your info environment, you'll keep the project environment as development here. For test, you'll mention it testing. For UAT, you'll mention user acceptance testing. So once you change the port, let's say right now I've set the port to the active profile to production. So it will read these properties. And if I hit the actuator info endpoint after starting the application, it will print these properties. It will not print the default properties from application.properties. Let me demo this. So my application has started. It's running on port 8084, which is the production port. That means my application is reading the properties from here. So here you can see I have this information. For environment, it should print production. It should not read from application.properties. It should not print local. So if I go back here and make this port 8084, and yes, and then if I hit the info endpoint, you see I'm seeing production here. If I set the active profile as UAT, first of all, my port will also change because in UAT I've set port 8083. I'm just waiting for the application to start in the background. So you see now I'm seeing user acceptance testing. So this is how it works. Now I'll set back my active profile to prod. And the port will change back to 8084. So if I change it back to 8084, I'll see production here. So is this clear? Guys, is this clear? Yes, Venkat, it is externalizing the configuration. It's only called like profiling is just a term for externalizing your configuration into different property files so that you have this segregation. You can, it's not just environment that you can use this, you can use it for other things also. Like I have used it, let's say I want to build the same application which connects to MySQL database. So I wrote application dash mysql.properties and I connected to Postgres also. So I created another file application dash Postgres dot properties, and then I set the active profile as either MySQL or Postgres. This is another use case. You can have any number of use cases that you like, but the generic use case is the environment specific properties that you place in environment specific property files that we create like this. Okay, going to the next one. Next is model design. So what is model design? It's nothing but a POJO design. So we're going to create this Microstream class and implement the concept of encapsulation. Encapsulation means private variables and public getter setter methods. So this is my model package. Inside this model package, I have this Microstream class, and this Microstream class, let me just revert the code to the simple code, has course name, course type, instructor name. Let's say for a moment, I don't have these annotations. Now, how do I generate? So I can press Alt Shift S, or alternatively, I can click right click, source, generate getter setters, select all, click generate. This will generate getter setter methods. I can similarly also generate toString. I can generate constructor, all args constructor, then default constructor. So this is how we can do it. So this is a common way of creating a class in Java. Now we can also create object. Right now I need to, I think, change some code because I'm referring to the full name. Or let me make it for now return null. Okay. If I want to create an object, so I can just simply create a simple object like Microstream, like how we create in normal Java. I can set the constructor name Samarth. Then we can set the course name Spring Boot. We can set the next is course type IT. Okay, so we can set these things like this. Then we can also print it like this. Okay, I think there is something gone wrong here. What is it complaining? Is undefined. Yeah, I have not saved this file. That's why it was saying undefined. It will fix now. So yeah, the typo. Done. So we can see it's printing here. So this is how we can create model and we can test it by using command line runner. One thing, whenever you implement command line runner, whenever you override this run method, whatever you write inside this run method is executed as soon as your application starts. That means, let's say, if for example, if I'm writing this here, now can you tell me in chat, like what will get printed first, hello world or DevTools in the console? What will come first, hello world or DevTools? Perfect, DevTools. Because whatever you write in this run method gets executed as soon as your application starts. And our application starts when this line is executed, line number 22. So as soon as this line is executed, whatever is written here will be executed, and then whatever comes after will be executed. Now let's save this and see this in action. So we can see DevTools got printed first, then Microstream also object got printed, and then in the end, hello world got printed. Okay, so that's about the model. So we have seen the shortcut how to use Eclipse IDE, that source generate thing, to generate all the things, getter, setter, toString, constructors. We have also seen tested our model, this model, Microstream model, class using command line runner's run method. And we have understood when to use command line runner. So when to use command line runner, whenever you are building your application and you don't want to wrap it with the API, you want to quickly test your method, just quickly test your method inside this and delete it. And delete the code that you have written here basically. Once you have tested, delete it. So that is when you use command line runner. So we have tested our model design with command line runner. Next is Lombok. Now tell me honestly, how many of you are successfully able to compile the Lombok code after cloning this project, or how many of you are getting some error and are not able to resolve the error? Has everyone successfully compiled, like is not facing any issue with Lombok? Or some of you are facing issue with Lombok annotations? So the Lombok annotations in a way like these. Are these compiling or giving error to you? If everyone is if everyone has this working, you can write working in the chat. If you're facing any issue, you can speak up. I'll help you resolve it. Maria, your issue seems very different. Okay, Maria, I can help you if you can share your screen and show me the error. Then only I can help you with that kind of error, because it's a very different error.
Hi, just 1 second. I'm new to using Zoom. Can you see my screen?
Not loaded yet. Let's give it a minute to load. Yeah, it's loading.
Okay.
Yeah, loaded now.
Perfect. It's still
So,
showing now.
yeah, it's fine now. Okay, now can you have you made any changes in the code so far?
Actually, I was just trying to do the same changes as you was showing to us, and after I wanted to use the dev tools, how you explained to us, and every time when I was changing something in the code, that
Okay, in IntelliJ you need to activate annotation processing. Maybe Michael can tell you like how to enable that annotation processing.
oh, I had that window here down, and it told me to
Go to project settings. He's giving the instructions.
uh,
File, project structure, I think, or settings maybe,
instruction,
or settings. Yeah, settings part,
file
settings below.
settings.
A search compiler above. Compiler.
Oh,
Yeah,
here.
Java compiler. Yeah, compiler.
Yes, here.
Now add annotations. Add annotations. Just click on compiler once on the top. You have annotation processors, right? Below annotation processors,
Yes,
I think
I
something in
found
that.
it. It's enabled.
Enable CMD plus folder CMD plus.
RAM processor.
And enable CMD also. Where is the CMD?
Same processor path.
It seems it is enabled. Okay, have you downloaded the Lombok plugin?
Yes, I already have it.
Can you check it quickly? Go to the marketplace.
Yes.
It won't be here. I think marketplace is outside somewhere.
Actually, I believe it's in plugins or something. Plugins.
Yeah, plugins. Type it's just yeah, Lombok.
Lombok, I have it.
Did you restart your Eclipse after installing this?
Yes, yes, I already have Lombok before this meeting with you guys. So
Okay. Can you please check whether correct package is imported? Can you check whether correct package is imported? Which place will it be? Plugins, it is named try project build. Okay.
Maven, I did Maven clean and then compile.
Okay. Is your build automatic selected above?
How can I
This
check this?
This may be above some setting is there. Like in Eclipse, we have this enable build automatic build thing.
I believe it's enabled because every time when I change something, or it's because the dev tools. Every time if I change something in the code, then
It's fixed now. It seems it's got printed.
No, wait. Okay, you see?
Okay, it's breaking. Generated class because data is null. Can you Google this error once? See which data it's referring here.
Uh,
And Maven reload. Okay, you need to do Maven reload also. Above
I
there is this.
already checked. It is, I know, Maven reload from here. Yes, I did reload all Maven projects from this button. Already checked this. Okay, so you want me to Google the error from here or
Yeah. Error. Google the error from here.
1 second.
Maybe now we have ChatGPT. We can directly ask it. Tell us the resolution fast. Right, Spring Boot null. Complete the null and Spring Boot. Just here, Spring Boot. Yeah. Anything we are missing, guys, for IntelliJ?
I was thinking maybe it's from application properties.
Can you enable prod properties for once, because you have incomplete properties here? Just comment out line number 2, uncomment line number 10.
Comment number 2, yes. And
Uncomment line number this, sorry, product this, not 10. My bad. I'm not able to see here. 18.
18. Okay. Okay, if I put like this, I already had this uncommented, this line uncommented, and I had this another error. Let me 1 second. Now it's building. And vision.
It's running.
It's still building.
Yeah, disable the test and run. We are not using test. There is an option above that ban button in the Maven part above. Just click that. That would skip test.
Oh, I know. You mean from here?
Beside here on beside right side. More right. Left little. Left. Left. Yeah, I think this. Yeah, skip test.
Skip test. Okay. Okay, and let me change something here so I can.
Just try to start your application now.
Okay, from the bottom. Okay, stop error.
Working.
Okay, and now if I do some changes here, and let's do building. You see, this is another error which I noticed in the beginning of the of your training.
Let me see. Bookstore CRUD server. Okay, IMPL not found. Okay, it's not able to find a class.
Yes, and the class I can find it if I search it it's this one. If I fill bookstore CRUD service in Palermo, it's this one, and I can find it.
Yeah, correct. Can find it. Seems like some DevTools issue with IntelliJ. It's not able to properly reload. Yeah, IntelliJ has issues with DevTools. That is where I recommended using
Eclipse.
Yeah, for this, because even I prefer IntelliJ. It's a smart tool, but with these dependencies that I can code fast, I cannot use IntelliJ much. Like sometimes it gives a lot of different issues.
Okay, I understand. So it's because of IntelliJ. Okay.
Yeah. These are IntelliJ specific issues. Like Eclipse also has its own set of issues, but I already know quick resolution for all the issues.
Okay, thank you.
All right.
Okay.
Can you stop sharing the screen? I'll quickly share again.
I want to do this, but I'm new with Zoom and I don't know how to stop.
Oh, okay. Wait, I'll do it.
I'm using usually Teams. Thank you.
No worries. Guys, can you see my screen?
Yes.
Yeah. For now, Maria, you can rerun your project. You don't need to install Eclipse. You can just avoid using DevTools. You can manually stop and start the project for your code changes.
Okay, thank you for the advice.
So Lombok Framework. So Lombok is a framework that helps us to avoid boilerplate code. What is the meaning of boilerplate code? So all these things that I just commented out, these are the boilerplate code, like the getter method, setter methods, all args constructor, default constructor, toString method. So this is the boilerplate code. Now, if I don't want to write so much of code or generate so much of code, I want my class to look neat and clean. I can use Lombok annotations like @getter for generating getter. So if I save this, I'll have getter methods. You can see I have getter methods. I can create setter methods with Lombok annotation @setter. If I save this, now I'll have getter methods plus setter methods. Now, if I want toString, I can write @toString. It's another Lombok annotation. You can see these are all Lombok annotations. Now, once I add toString here, I'll get the toString method. If I want a all args constructor, I can write all args constructor. It will give me an all argument constructor. So this is my all args constructor with all the three fields: course name, course type, and instructor name. Now in Java, we know if we create our own constructor, Java takes away the default constructor. So we can create the default constructor with @noargs constructor and so on. So if you don't want to write so many annotations, so what we can do is we can use convenience annotation, which is @data. So @data is a convenience annotation because it's combination of @getter, setter, @required args constructor, toString, equals, and hash code. So it will give us all those things. So now we'll have our getter method, setter methods, all args constructor, default constructor, everything. Since we don't have a requirement of required args constructor, so we are not getting that. Required args constructor, if you want to learn about what is required args constructor, I'll try to just create a YouTube video on that later on, because right now that's not the part of the Spring Boot, it's just Java part. These basic things are fine. Next is, okay, so this is how we can generate everything that we want. And similarly, I've also generated the builder design pattern with @builder. So @builder generates the builder design pattern for me. So if you don't know about builder design pattern, I have a course on Udemy which talks about all the creational design patterns in Java. You can enroll for that Udemy course. I'll share my Udemy course link. Don't go for the Spring Boot course. You are learning also here. That's why. So you can just take the creational design pattern course on Udemy that I have. Okay, moving to the next one. So what the Lombok annotations does, it generates the code in the background for us so that we don't have to see it over here, but it's there in the background. If we view the outline, we can see this class has all these methods. We just don't see it here, but it's there in the background. So we can see in the outline. So that's about this. Next is first time configuration for Lombok. I've already explained you in the start. First time configuration is we find the jar file. This is for Eclipse. We find the jar file, we'll double click and run the jar file. It will locate the Eclipse exe files in our laptop, and we just select install, update, quit installer. We come back to our Eclipse. We go to this project, clean. We clean the projects that we have. Then we restart our Eclipse. And after restarting, we check over here and we should see this over here. This is the first time configuration. Next is how to get rid of boilerplate code. We have already done this. We have got rid of all getter method, setter method, toString method, all the code that we had by using Lombok annotation. And next is, now that we have learned about these Lombok annotations, that is all this hands-on was about. Next is the controller mapping method dispatcher servlet. What are controller? So controllers are simple Java files in Spring Boot that are marked with @controller or @rest controller annotation. When I say class is marked with something, what it means? It means this: at a class, at top of the class name, you add this kind of annotations. So a controller class is either marked with @controller or @rest controller, any one. What are the different types of HTTP methods and respective mapping in Spring Boot framework? So we have get method. For that, respective mapping is @get mapping. This is referring to get method. Then we have post method. This refers to post mapping. Delete method. Spring Boot annotation for this is @delete mapping. Put method, put mapping. Patch method, patch mapping. This is an interview question. What is dispatcher servlet? We don't really have to care much about it, but let me explain. In Spring Boot, dispatcher servlet handles an incoming HTTP request and delegates a request to its respective controller mapping in controller file for processing and sends a response back. Now here we have the info endpoint, which basically provides this information. Let me simplify the code for now. So let's say this will return a Microstream object. So what dispatcher servlet will do? Okay, let me come back to info. Yes. So when I hit this API, what it will do is, this is not actuator info endpoint. Don't get confused. It's a info endpoint which I've built it. I'll explain you how to build this in the upcoming topics of this course. So right now, just bear with me. This is an info endpoint. Whenever I hit this endpoint, the request from this browser, Chrome browser, goes to the application. And in the application, I have something called as dispatcher servlet. So this dispatcher servlet receives my request with this parameter, like with this path at /info. And what it does is it tries to find the controller file which has this mapping @info, and it knows it's a get call that I'm getting here. So it will try to find the get call with info, and once it finds the matching method, or call it controller method, then it will process this request from this method. It will process this request from this method here. Now if I try to give it something which is non-existing like this, it will give error because dispatcher servlet was not able to find the respective mapping. That's why it gives this error here. White label error page. So it's not able to find the respective API in my application. So the job of finding the respective API is the work of dispatcher servlet. So we don't have to we don't have to worry about it much, but just an interview question. So I just thought of covering it. Very famous interview question. Okay, going to next one. Understanding difference between REST controller and controller annotations, use of get mapping annotation. So let's learn how to use these annotations. So @REST controller annotation is a convenient application, convenient annotation. That means it's a combination of these two annotations. And let's learn how to use get mapping annotation. So Microstream controller, this is my controller file. Let me make some changes to simplify what you're seeing here. Give me a moment. So this is our controller class, and since it's a controller class, we have marked it with @controller. And here we have a service. Let's say we don't have this service for now because I've not taught you services. And let's say we don't have this also. Let's say we have some simple get mapping. Let's call it first API. Okay, let's say we have this first API, hello world. And we have named it first API. Okay, let me see what's going wrong. Yes, so let's try to hit it again. Still breaking. Okay, so I think for string also we need @response body. Before, in the older versions, we didn't need this for string. I think in the 3 version onwards, we need this. Let's refresh this and we can see hello world. So if you're using @controller on top of all your API methods, if it's returning a certain object like string class or any other custom class like Microstream, you'll have to use response body. Okay, so if you're not using @controller, instead if you're using @REST controller, which is a convenience annotation, because @REST controller annotation is a combination of @controller and @response body annotation. That is why it's called as convenience annotation. So if you're using this annotation, you don't need to add @response body on top of all your methods. Now, if we test this out, it will work. Before it was not working, but now it works because we don't need to add this now because we are using this convenience annotation, which already comprises of this annotation. So that's about how to create APIs, and let's create this another API also. Let's say we have this class, service class. Let me explain you service class also. We cannot have this. Let's get rid of this because we cannot have two methods with same name. Let's go to this class. Yeah, let me go to the class rather than the interface. So this is the class Microstream service IMPL. Since it's a service class, it's annotated with @service. And I've just wrapped like getting these methods from the interface, overriding from the interface. It's not mandatory to have an interface, but it's a good design to code by the interfaces rather than by the concrete classes. So I've just created the interface, implemented the interface, and overriding the interface. The getInfo method, which will basically return me Microstream object, and then we have custom info method. Let's focus on the getInfo method for now. So I've auto-wired the interface here. Since this interface is being implemented by only one concrete implementing class, so it will automatically create object of Microstream service IMPL class at runtime. So either we can also auto-wire by the concrete implementing class, or we can auto-wire by the interface. It doesn't matter. If your interface is being implemented by only one class, so you can do this. If your interface is being implemented by more than one class, then there is a concept of @primary and @qualifier. I would recommend that you can study that post this training because if I cover that, we might miss whatever we have intended for the training. So you can study that post learning from this training. If by the end we have time, we'll try to cover that. Okay, so this is done. Okay, this we have auto-wired the interface. So at runtime, it will create concrete implementing class of this interface, which is this class object. And here we can see we are calling the getInfo method from this class, Microstream service IMPL, and it will execute this code. So whenever I hit the info endpoint, the request will come to this controller, and from this controller, it will be redirected to the Microstream service IMPL class. And this has this getInfo method, and this code will be executed, and the Microstream object that we are building, Spring Boot design patterns, course IT, name Samarth, will be returned. So let's see this in action. Let's type here info. And here we can see it's returning the same object that we are building in our this Microstream service IMPL class. Okay, so this is how we can create.
Question here.
Okay, go ahead.
So for I know you said auto-wired you can call it later, but just a quick question so that my understanding is good. So auto-wired, basically you're talking about a dependency injection and then like,
Yes.
the singleton card.
IOC, yes.
Got it, thank you.
So auto-wired, that's the theoretical part, this is the practical. So in theoretical part, what we say is like this is same as creating object basically. This is same as what we used to do in core Java. Like the alternative of core Java would look like this, In core Java, it would look like this. In Spring Boot, it looks like this. So this is the Spring Boot way of doing what we used to do in core Java, like this. So let me type here core Java way below and Spring Boot way below. Yeah, Spring Boot way below. In Spring Boot, we create objects like this. In core Java, we create objects like this.
Thank you.
Okay, let's go to the next one. And the theoretical part for this is like, this is called as dependency injection. Since in core Java we had to write like this, we had to mention which object to create, and here we don't have to mention this. If there is only one concrete implementing class for this interface, it will automatically create object of that concrete implementing class here. So since we don't have to manage this part, that's why it's called IOC, inversion of control. Like the control of which object to create is taken from the developer's hand. Now it's in the hands of Spring Boot, and Spring Boot decides which object to create depending upon the situation. Like our situation is we only have one concrete implementing class of this interface, so it's creating object of this class at runtime. If we have more than one class, then we need to mark one class as @primary, or we need to use @qualifier annotation to provide a qualifier component name. There is one more way also, which I know, but I'll show that way by the end if we still have time, which is not over the internet. Okay, I'll just keep this code over here for now. Okay, so this is the info endpoint, and this part is done. Next is post API. Okay, let's create a post API. So let's create this post API, and I remember I had commented out the code in this class. Yes. So let's add this back. This would change from this to, I'm just hard coding the name for now. Okay. Or maybe I can have first name plus last name. Concatenated. So get custom info. So whenever a post API call, which is referring here as @post mapping, this custom info is hit, it will direct the request to Microstream service get custom info. Open the implementation. It will land to this class. It will return this. So it will take all these parameters from here. So it will take name and this instructor name, and will take the first name, last name, send it here, and concatenate it back here. So let's see this. So we cannot hit a post API from browser. So we need Postman for that, or we need to have Spring Doc to hit it from browser. So let's launch the Postman. This is the Postman. Here I have instructor name. So I need to change it to first name, last name, first name. Yeah, let me check back here. So yeah, we have instructor name only, so I don't need to replace it. And here I'm passing instructor name as Samarth Narula. So it will take this instructor name and will return it back. Okay, it's returning null because we have this instructor name as, let me see, its full name. That's why. So if I replace it back, I don't need to, if I just write string here, it will work. For this kind of object, we need a different format. And for that format, let me open Swagger doc to see that format so that I don't have to spend time in building that format. It is localhost 8084 / Swagger UI index.html. So custom info, try it out. This is the format. And let's go back to the Postman. Let's hit this from here for now. Course name, let's say Spring Boot. Course type IT. First name Sam. Let's say full name Samarth. Narula. Execute. And here we can see the URL. So this is the complete URL. So it is like first name equal to first name and last name. And here the mistake I had done is instructor name. So let's replace this, send, and now we are seeing the correct response. So since I've not added any space, that's why the name was coming 1. So if you want to add additional space, you can add additional space. Then go back here, let the application restart. And for the spaces in the name, it will have this %20 character and this. So using Swagger UI makes our life very much simple with Spring Boot. We don't have to spend time in creating these APIs here in the Postman. But you should know Postman, because when you're using some external APIs, it's not necessary that they will have Swagger UI for you. So you should know how to use Postman. It's mandatory for a developer. Okay, so coming back here, so we have seen how to create Post API, how to test it with Postman. I have installed this Postman using the Chrome plugin, using the Chrome Web Store. I've installed it and launched it. Okay, we have also done this. We have cut down the boilerplate code by using @data annotation. We have seen this already. It's a combination of all these annotations: getter, setter, required args, toString, equals, and hash code. Next is Swagger part. We've already done this, but I've shown you the Swagger UI. This is the Swagger UI. But how do we get this? How do we enable it? It's very simple. All we have to do is add this dependency, Spring Doc, Open API, Starter, Web MVC UI. Just by adding this, we get this beautiful looking Swagger UI, or call it API documentation. From here, if you want to test a API, for example, info API, you just click this, click on this, try it out, and click on execute, and it will return you the response. If you want to test a post API, custom info, you expand this, click on try it out, you give your course name. You can see this is the mandatory parameter, course type, instructor name. This will ensure that you never pass, you always pass the mandatory parameters, because it's showing required, and if I keep this empty, it will give me error. So this ensures that I don't make any mistakes in my API call. So this automates a lot of stuff for us, and it makes our life very easy. So this is the Swagger UI part. So what is Spring Doc? It's a framework. It generates API documentation. This is nothing but API documentation. We didn't have to write anything for generating this code. We just added this dependency, and it built this beautiful looking UI, which is accessible on this URL, Swagger UI /swagger-ui/index.html. Just this much. This is not needed. Just this much. I'll share this URL over the chat. Okay, before we go to module 9, let's see so far we have completed till which point. So far we have completed till here, module. Okay, let's see again. Yeah, module 9. So we have completed till module 8, Swagger UI. We'll take a 5 minutes break, then start with module 9, module 10. And after module 10, let's aim for Microstream. We'll finish Microstream, or let's come till here, maybe to this point, and then cover for Microstream, and then get back from here, from this point. Let's figure it out. Let's move to this module, advanced concept implementation and controller tier. As part of this hands-on, we're going to learn. So we've all done this: all args constructor, no args constructor. So here we've already learned this. We have built this class. We've used these annotations @ all args constructor, @ no args constructor, and we implemented. By adding these annotations, it created all args constructor and no args constructor for us. This is all args, and this is no args. So this one is done. Now, what is telescoping constructor design pattern? Telescoping constructor design pattern means having all possible constructor for this class. There are how many all possible constructors which can be created for this class? So the answer is, since we have 3 variables, it is 3 factorial. 3 factorial means 3 into 2 into 1, which is 6. So we can have total 6 constructors for this class if we combine different constructors, like one constructor for each field, like one for instructor name, another one for course name, another one for course type, and one with only these two, one with only these two, one with this and this. This way we can have 6 constructors, and one with all args, one default. So in this way we can have total 6 constructors. So if you have all possible types of constructors, it's called as telescoping constructor design pattern. It's the worst kind of a design pattern which you can implement. So never do this. the best kind of a design pattern which you can implement for complex object creation is builder design pattern. So let's learn how to create builder design pattern. Let's get rid of this. We don't need this. So in order to implement builder design pattern, we write here @builder, and this creates the builder design pattern for us. Now, if you view the outline of this class, you'll see this static inner class Microstream builder, which has got created, and all the builder design pattern code has got automatically generated. As part of this course, I'm not going to explain you how to design your builder class manually. So right now you can use this Lombok annotation and build it. But if you're interested in learning in core Java, like without using this annotation, without using Lombok, how to write the code of builder design pattern, then I recommend you can enroll to my Udemy course of Learn Creational Design Pattern. In that course, I'm walking through all the possible creational design patterns and different ways of building a robust classes for singleton, like how to protect your singleton class against reflection, against multi-threading, against cloning, against everything. So I'm covering all possible kinds of interview questions and all possible kind of scenarios that you might encounter while working as a Java developer in your career. Okay, so coming back here, so writing this annotation has generated all the code. So let's learn right now how to use this generated code. Since we added that annotation there, it has builded this part for us. Let's say instructor name. So all we do is we write like this: Microstream dot builder course name dot course type. Okay, let's see like this: builder dot course name. We provide the course name Spring Boot design pattern dot course type IT dot instructor name Samarth Narula dot build. When we do this dot build, it builds the Microstream class. Until this point, it's returning Microstream builder, that static inner class that we have. So this is the builder design pattern code for creating object of Microstream. You can create it, basically we are creating it in inline. So if you see, it's just all in one line. So we have created this class in one line. Let me format it for readability. Now you can see this is how it looks. Okay. Is this clear to everyone? Builder design pattern, how to use it. You enable builder pattern for a code by writing for a class, Pojo class, or for any entity class by writing @builder. In order to use it, you write like this: class name. It's the class name dot builder dot whichever fields you have, course name, course type, instructor name, and in the end you write dot build. It will build the object.
What's the advantage of this builder?
Okay, so it's used for it's basically a way of coding, like instead of writing dot set, if you have complex object, it's good for complex object creation. This is a simple object because this object doesn't has other much objects in it, although it has a string object, but I would not rather say this class is complex object. But if you can imagine, instead of simple object like this, if you have something like this, let's make this code change quickly. Let's say instead of string, we have another class full name, which has first name and last name. And we are having instructor name like this. We need to change here also. So for complex object creation, it's recommended that you use builder design pattern. So you can see, instead of writing so many lines of code, I've created the full name inline inside this same line. It's actually one line, but just for just for readability purpose, I've written this into two lines. This is first and second, but it's in the end one line only. You can write all the code in one line if you want.
So this has nothing to do with Microstream, right? It's available as
No, it's nothing to do with Microstream so far. Microstream is a library, Java library. I'll come to Microstream. Once you know till the basics, like how to create service class, controller class, APIs. Then I'll come to Microstream, because if I try to explain Microstream right now with the Spring Boot project right now, you won't be able to understand this project at this point. I mean, you might be, but there are many other people, right? So not everyone will be able to understand Microstream at this point if I explain at this point. So I need to first bring everyone's knowledge to the point that they are strong with the foundations, and then they can understand. Okay, so we have seen builder design pattern. Complex object creation also we have seen in the way, because this is a complex object. Instead of having simple string, I've added a custom object full name, which is first name and last name. First name and last name. And we saw how we can create complex object with builder. Like for Microstream, we write builder course name dot course type dot instructor name. Inside instructor name, we are writing full name dot builder dot first name dot last name dot build. We are building object inside building another object. This is the real use case of builder design pattern. So whenever you have complex object creation requirement, then that time you should implement builder design pattern. Don't implement builder pattern for simple object creation. It's not meant for simple object creations. It's meant for complex object creation. This is also not very complex object. A very complex object would be, let's say you have 50 more fields like this, or 20 more fields with custom classes, custom class types. Then in that case, it will be a complex object if you create a object of that kind of a class. So in that kind of a scenarios, you can use builder pattern and write the code in one line or in a more readable way. Actually, in start, you might feel it's not very readable, but once you get used to of builder, it will become very readable to you. Let's go to this hands-on. Introduction to service tier and creating service class out of controller methods. So basically, this is nothing like I have the controller class here, right? So if I have not written the logic in this class, okay, let's go back to the simple class. If I have not written the logic in the Microstream service IMPL, if I would have directly written this logic in the controller, I could have extracted out the controller class. But let's say I have right now written the logic in this class. Let's say I don't have this interface right now. If I don't have this interface, and if I want to extract this interface out of this class automatically, for example, I want to do something like, let's say I don't have this interface. Let's say I don't have this interface right now. And yes, so if I don't have this interface, I need to do like this. So if I don't have this interface, and if I want to extract interface out of this class, I can do right click, refactor, extract interface, and provide an interface name, Microstream service. So I will provide an interface name, select all the methods, click OK. It will create the interface, automatically implement the interface, add these annotation. Now I can simply drag and drop this over here into the 1 minute. I just dragged and dropped the POM file, I think mistakenly. Oh, this is going to mess up. Yeah, let me drag and drop this over here. So I've dragged this into a separate package and done. So this is how we can extract out interface out of a class, and that is this hands-on about. And also after extracting the interface into a different class, if you want to add @component here, you can add, but it's not mandatory. It's optional. In the older versions of Spring Boot, like Spring Boot 1 version, we had to do it, but now we don't have to use this annotation anymore. Let's go to this one. Initializing logger with Lombok annotation @SLF4J. We'll see the functional style of logging. So let's go back here. Okay, so here, let's say I don't want to use sysout, I want to use logger. So I will add this @SLF4J, and this will instantiate the logger instance for me in this class. This is a Lombok annotation. You can see in the imports. It's a Lombok annotation. And now I can simply use this like this, log.info. And here I'll write the Microstream. And here I can, okay, it's the opposite way. Microstream, obj, and the arrow function, evaluate, and evaluate this one. Done. So now you can see in the console that it's getting logged as info log. And this is the Microstream object, and the object has got evaluated in this parenthesis, like this has got substituted here. So this is how we can instantiate a logger using Lombok annotation @SLF4J, and this is how we can log the object. Is this clear to everyone? What about others? Okay, perfect. Next is, yeah, different logging levels. So what I've shown you is info. Similarly, if you see, we have debug, then we have error, we have info, we have already seen. Warn is there, trace is there. So we have trace, then we have warn. Yeah, so these are the different logging levels which we have available in this logger instance. And this logger has got instantiated from Lombok annotation @SLF4J. And we have seen this functional style of coding. This is nothing but functional style of coding. Next is introduction to embedded database H2. How to use embedded database H2. Let's understand what's an embedded database. So as the name implies, embedded database, right? It's embedded. So as the name implies, it doesn't run as a separate process like your normal database. What's a normal database? Like MySQL, Postgres, MongoDB. These are your normal SQL, NoSQL databases. So this embedded database is a database which is basically embedded, or you can say it's running inside your Spring Boot application. Let's understand this better with help of this diagram. So let's understand where and how does embedded database runs. So our Spring Boot application, we know it's a Java application here and it's running in JVM. So this is the JVM. Inside JVM, we have the embedded Tomcat server. This application is running inside the embedded Tomcat server. So the embedded Tomcat server is running inside JVM, and the embedded database runs inside this embedded Tomcat server. So this is where it runs. We have the JVM which runs on this laptop. Embedded Tomcat server runs inside, runs as a JVM process, and embedded database H2 runs inside this embedded Tomcat server. That means what? If we terminate this application, which is nothing but embedded Tomcat server, it will also terminate the embedded database. So all the data which is persisted into this embedded database will be lost on application stop. Even if we start the application again, the data won't be saved, it will be lost. So it's used for, what is this used for then? If data is just temporarily stored, it's used for temporary data storage. It's beneficial to have temporary data storage when you're architecting your application from scratch. And when you're architecting your application from scratch, that time you're not sure about the schema of your database tables. So you have to do a lot of cleanup. So if you don't want to spend a lot of time doing that cleanup, you can use H2 database. So you do not have to spend time to clean up the data. You can just keep storing and restarting your application. The data will be cleaned up on each restart. So you can use H2 until your company has not provisioned infra, or if you're doing a POC, like proof of concept, you're building some Spring Boot proof of concept, or you're doing some POT or max to max for MVP, but you cannot use H2 database for production. If you if you use for production, it will have a lot of issues like this, because H2 database data is getting saved on your application in your heap memory, right, in the JVM heap memory. So it's not meant for production, it's just meant for creating your application and then replace with the proper database credentials like MySQL or Postgres.
Question there. So can you control yourself what you want to store in there, and then can you use it as in-memory storage for the application?
Yes, it's kind of a temporary in-memory storage.
Okay.
Now let's see how
we can store in cache, right? Instead of doing the S2 database, because every time applications in a data is erasing, right?
come again.
Yeah, instead of S2 data, you can use cache data, right? Because every time it's data is erasing every time application restart.
Yeah, caching you can use, but caching infrastructure is expensive. And if you are using Redis, you can use Redis also. But in Redis, data is not cleaned up. But if you want to clean up, when you're coding an application from scratch, like when you're coding something from scratch, you have to do a lot of, cleanup in the database if you're using proper database or Redis also. Because the data schema in Redis, you'll have to update the data schema in Redis. You'll have to basically go to the Redis UI or whatever it is and clean the data there, recreate the table in the Redis, and then restore the data. The cache, I'm not sure if the data will get automatically updated or it will just delete the old data and replace it with new data that you're passing or the updated schema.
Okay.
I have a project on Redis also, Spring Boot Redis. You can just search in my repo, you'll find it. It's but very old, like 2020 project or 2019 project.
Okay.
Let's see now how to configure the H2 database. In order to configure, which we are using production. So in order to configure the H2 database, these are the properties. This property enables the H2 console UI so that we can access it. This is the URL of our H2 database, not URL in a way like URL to access it, but this is something I'll show you where we put this. And this is the driver name. So since we are using H2, we are writing H2 driver. If you're using MySQL, we'll use MySQL driver. If you're using Postgres, we'll use Postgres driver. This is the username. I've purposely not set any password because I don't want to re-enter the password each time the application starts and each time I have to log into the H2. So now that we have this running, let's copy this. Let's go to browser. Let's go to H2 console. It's H2 -console. This is the H2 console. Here we need to paste our JDBC URL that we copied from here. We need to copy this username also, and we need to paste the username here. Since we have not set any password, so we don't need to enter anything here. Ensure your driver class is set correctly here. And this server setting, you can select generic H2 and generic H2. If you want to test your connection, you can press test connection. It shows test successful, and now connect, and we have successfully connected. So it's showing you this bookstore because I have this entity class. So you can do like this, but right now I don't want to come to bookstore. This is how it looks. And if you want to test some queries, we have this sample script here. So if you want to drop a table, right now we don't have this table called as test, but if you want to run one query, you can select it and click run, run selected. If you want to run everything, you can just press this run and it will run everything. Keyboard shortcut is Control Enter to run everything. And here we can see this test table is here now. Let's drop this again. Let's select this, run selected. This is how we can execute the queries on H2 console. This is your H2 console. There are different parameters like the normal database IDEs, like max rows, autocomplete on off, auto select. We don't need to do anything over here. Max rows and all. Just we should know how to write the queries here and run the queries here. So that's about configuring H2, accessing the H2 console UI, executing the queries on the UI. Now the next module is entity classes. Before we proceed to entity, are there any doubts with H2 database?
Not a doubt, but clarification. So just you have the dependencies, you enable that in the properties. That's it. You're good to go.
Yes, that's all. Very simple, right? We just add this H2.
Samarth,
Mhm.
so now how do we replace H2 database to MySQL or Postgres? So can you
Yes,
just
good
demo?
question. For demo, I need to set up a MySQL or Postgres server, which I have not in my local. And for setting up cloud, my cloud account just recently got disabled. Just closed it. So all you need to do is just have a proper database in background and replace the properties here. This will remain, this will change. Here it's H2, so it will become something else. For MySQL, it will be MySQL. Postgres will be Postgres. This will also change. This part would change. This would become the driver class name of MySQL or Postgres, and username, password, you can keep it same. These two things will change.
Okay, thank you so much.
All right, let's move to this. What are entity classes? So you can imagine this is a Java class bookstore. If we mark it with @entity and @id, it becomes an entity class. So when a normal class becomes an entity class, it gets mapped to a database table. So this bookstore becomes bookstore table, and these column and these variables, ID becomes ID column, name variable becomes name column, books variable become books column, and the individual objects that we create, these one object is a one row in the database. So if we create one object of bookstore and we insert it into the database, it will be inserted as a one row in the database. So we can imagine we have this bookstore, Atlantis books, and the books, this bookstore has these books, Mars, Red Planet, Jupiter, Gas, Cloud, and we have this another bookstore with these books. Let's see this in action. So let's see how this class looks like. So here is the entity package. I'll close all the other tabs. And this is the entity package. This is the entity class. Since it's the entity class, I've marked it with @entity. And in JPA, you need to have this @ID. So we are marking this ID as a primary key by using @ID Jakarta persistence ID. This import has changed in the Spring Boot 3 onwards. Remember this. In the older versions, I remember there was a different package import for these annotations. Now that we have marked this bookstore as an entity and this ID as a primary key, this bookstore class will be mapped as a database table. So if we go to H2, we can see this bookstore is coming as a table. If we expand this, these are the columns. So there is an ID column, books column, name column. If we click this bookstore, it will create this select query and we can run it. And we can see these are the columns and we don't have any rows in this bookstore table so far. We can also insert the values into this by writing the insert query, but let's not focus on that for now. We'll insert by writing JPA methods. Now let's cover the JPA methods. I think we can cover everything today in our time frame. So let's focus on the JPA. Let's come to this module 13, understand and implement JPA with Spring Boot. So let's understand what is JPA. JPA is a specification, and what is Hibernate? Hibernate is its implementation. So JPA also has other implementations like Top Link and Eclipse Link, but Hibernate is a default implementation of JPA. So if you remember, we added the JPA dependency, but did we add the Hibernate dependency? No, right? We didn't add the Hibernate dependency, right? That's because we don't need to. Hibernate dependency comes transitively from this dependency. If I press Ctrl on my keyboard and click on this, it will take me to the effective POM in Eclipse. So this is the effective POM of JPA, and this has the Hibernate dependency. So I don't need to add Hibernate dependency separately, but in the latest version, that is 3 onwards, we need to add these boilerplate dependencies, which should have ideally come transitively, like starter validation, Hibernate validation, Jakarta validation. So we need to add these 3 dependencies. Otherwise, you might get a lot of exceptions in the code. Ideally, these should have come from JPA dependency transitively, like how Hibernate is coming. Okay, that's about the Hibernate and JPA. So JPA is a specification, Hibernate is the default implementation of JPA. JPA also has other implementation which nobody uses, which is like top link and Eclipse link. What is ORM? ORM stands for Object Relationship Mapping, just a fancy word. When you mark a class as an entity class and it gets mapped as a table in the database, this is only called as ORM because your Java class is getting mapped to a table in the database. And when you save an object of this class, it will get saved as a row in this table. So this is nothing but object relationship mapping. This is referred to as object relationship mapping. What are CRUD operations? CRUD stands for create, read, update, delete. What is it used for? CRUD operations are used for creating a new object in the bookstore table, for updating an existing object, for deleting an object, and for reading an object. So CRUD, read, create, read, update, delete. So don't focus too much on the theory. You'll understand when we'll create the APIs. Let's start with that. But before that, we need to create a JPA repository. So let's see how we can create a JPA repository for performing CRUD operations onto our bookstore. And it's very simple. I have this repository package here. And in this, I've created an interface bookstore repository, which extends the JPA repository. And here it requires 2 parameters. So I'm building this JPA repository for which entity class, for performing CRUD operations onto which entity class. So I'm building this JPA repository, bookstore repository for performing CRUD operations for my bookstore entity class. That's why I write bookstore here. And what is this long? This long is nothing but the data type, or you can say the wrapper data type of my primary key. What is my primary key? ID. What's the data type of my ID? It's long. So I cannot write long over there. I have to write wrapper class for long, which is long, capital LONG. This code is nothing, but this code is your JPA repository, and you get all the methods from this JPA repository. I'll show you shortly how easy it is to perform CRUD operations now with your bookstore entity because of this repository. And also, since it's repository, I've marked it with @repository, but it's not mandatory to mark it with this, but it's a good convention to follow. Next is, let's create this class with create bookstore method, and we'll then wrap this method with the API. So we have this class bookstore CRUD service IMPL, and this auto wires my bookstore repository. So I don't need to worry about which class to instantiate. It will automatically instantiate the required class. I am just auto wiring my interface bookstore repository, which is a JPA repository, in my bookstore CRUD service IMPL class. Since this is a service class, I've annotated it with @service. And this is the create bookstore method. We are creating this method, which takes a bookstore as a argument and uses bookstore repository save and flush method. This is all we have to do. Dot save and flush. This is a JPA method, which is coming automatically from this repository, repository. And we are just passing the bookstore and it will be able to save it. Then we have created Microstream controller class. Let me correct this out. So we have created this controller class. Since it's a controller class, we are using this @REST controller. If you're building APIs, I would recommend you use @REST controller only. Don't go for @controller. But if you're using Thymely for something, then you need to use @controller in that case. But here you can use @REST controller for normal applications, for API based applications. And generally this is the use case for Spring Boot, to build API based applications or to build event driven architectures. Event-driven architectures we are not covering here. We are just covering API-based application, but there are multiple microservice design patterns that you can implement with Spring Boot. So this is a controller class. We've annotated it with @REST controller. We have auto-wired our Microstream service, which will indeed create a concrete implementing class of Microstream service IMPL for us. And this is the same thing, like design by interfaces, then by concrete implementing classes, one of the solid principle. The practical implementation of that solid principle, 12 solid principles, one of the principle in that. And okay, let's not open this one. Sorry, my bad. Let's open the bookstore controller. This is the bookstore controller. Again, it's a controller class, so we are creating we are marking it with @REST controller. To add a prefix to all our APIs, we are adding this bookstore prefix to all our APIs. We are directly auto wiring our bookstore CRUD service IMPL because I've not created interface for that. So I'm directly auto wiring the class. It's as good as creating object of this class into this class, creating object of this class over here. So in core Java words, it's same as this. It's same as this. Okay, the above line, this is same as doing this, but this is the Spring Boot way of doing it, as I explained earlier. So I've auto wired bookstore CRUD service IMPL here. I'm creating a post mapping API, and this is the API name, create bookstore. And here I'm passing the bookstore, and from this controller method I'm passing the bookstore to my bookstore CRUD service IMPL, create bookstore. And from this it will go over here, and from here it will use save and flushed API method and pass this bookstore to save and flushed API method and save it into the bookstore table. So this is how the request comes from browser. When you make a request, the request comes to this controller class. From controller it gets delegated to your service class. From service class it gets delegated to your repository class, and it saves into your database. Let's see this in action. So let's go to the Swagger. Let's click on this create bookstore, create. Let's give a ID. Let's say ID is 1, and the bookstore name is bookstore 1, and the books that it has is book 1, book 2, and click on execute. So here we can see it has saved the data. Like how we are creating this create API. So one more thing, this was a prefix, right? So if you want to see what's the meaning of that prefix, you can see here, this is how the URL is formed, localhost 8084, prefix, and our API name, and then all the parameters. So these are all query params. We'll not dive deep into what are query params and path params, but because we are using this Spring doc, we don't need to, break our head around it. But you can study this post this course. Like you can Google and study what are query params and path params. These are general API concepts. So in short, I can tell you, wherever you see this question mark kind of a notation, like question mark field ID and separate next field name and next field books. So whenever you see this question mark and notations, like implicit notations, this is a query param. Wherever you have like /ID equal to 1 / name equal to bookstore 1 / books equal to book 1 comma book 2, this is, then it's a path param. Right now it's a query param. That's the simple meaning of it. Now this is a path param. Swagger UI index, these are path parameters. Okay. So we have covered create bookstore. Next is get bookstores. Similar to create bookstore, in our bookstore CRUD service IMPL, we will write another method. and we'll use JPA method, bookstore repository find all, and this ready-made method will return us all the rows from the bookstore table. One more thing, since we inserted data, if we execute this query, let's reconnect. If we execute this query, we'll see our bookstore inserted into this bookstore table. Now same data, if we hit the next API, which is using this find all method, will return us all the rows from this table. Right now we have one row, so it will return us this one row. So yeah, here we go, next one. Similarly, we can add more books like bookstore 2, ID 2, bookstore 2, and it has the same books. And then we can play around with these APIs and we'll see 2 bookstores. And here also, if we execute, we'll see 2 rows. So is this clear to everyone so far?
Samarth, sorry to interrupt.
No worries, go ahead.
So can you just go once to Microstream controller class? So yeah, actually in the beginning, you said you are going to share one tip. You had commented this core Java way below. At that time, you said you are going to share
Correct.
one tip. So
Yes.
I just would like to remind you.
Yeah, I know. So that
And
I'll share
okay.
post we have covered all the content
Okay.
because
Okay.
that's not
Okay.
intended for this. Like first we
Okay.
need
Right.
to
Right.
cover, yeah.
Okay. Okay. Right. And just now I shared one message in the chat. Can you just respond to that?
Let me check. Response entity, it's not really needed in Spring Boot. Sometimes
Okay. I
request
mean,
body is needed, but response entity is not.
okay.
Yeah, response entity, I mean, okay, this response entity, I was getting confused with one annotation. So this response entity you can use if you like. So I have used it in some of my repos. I don't remember which one, but I've used it. Maybe in the older ones when it was 2 days of Spring Boot fundamental training in 2020. What was it? Day 1 maybe. Fundamental. Yes, 2021, I think. It's for changing the response code. Right now we are returning 200, which is default, right? Automatic. So if you want 201 for any object created, okay, like create should return 201 instead of 200. So you can use response entity to change the HTTP code. But we are not covering that as part of this because we cannot cover everything. So in this 4 hours, I want to teach you all the essentials using which you can start coding the real applications without having to dive deep into every concept.
Okay. Will this be covered in the advanced section later?
Advanced will have even more advanced things like Spring security and all. But I think if I have used this anywhere, I'll just cover it up. But you can check out the repos on my GitHub. I have written this somewhere, like in some places.
Okay, sure. I'll check it out. Thank you.
Maybe in 2021 training, because back in year 2021, this was a 2 days training.
Okay.
Like 16 hours. That's why. Okay, so create bookstore is done. Get bookstore is done. Next is get bookstore by ID. Similar to this, we have next one, create bookstore by ID. We are using bookstore repository find by ID. First, we are checking whether that bookstore exists or not by ID. If the bookstore, this will return optional bookstore. In optional object, we can use this is present. This will give true if it exists and false if it doesn't. If it doesn't exist, we are throwing this exception, runtime exception. There is no bookstore with ID. And if it exists, we are getting that bookstore and returning that bookstore. Then we have wrapped this method over here, get bookstore by ID. We have wrapped it. After wrapping it, we can just simply hit it. And we can check if a bookstore exists with ID 1 and it returns us the bookstore with ID 1. we can check if there is a bookstore with ID 2 and it will return us the bookstore with ID 2. Similarly, we have get bookstore which has particular books. Now this is little advanced code. Okay, so I think this is not intended to be covered here, but I've written this anyway. So this part, let me show it on my GitHub. I think I have used topic 6. I must have used a different set of slides, but it says 2023. Okay, let me show you this code quickly. Let me see if I've directly coded it here last time. Get bookstore by ID. It's a complex code. Let me give you that code right away. Or let me quickly build it. Fundamental 3.0.2. Source main. Controller IMPL. Okay, it's not here. Actually, this is not meant for this one. It's meant for the advanced code. I forgot to delete this slide out. But since I've given you this, shown you the slide, I'll just give you the code and we'll move to the next one and quickly explain you the code. If you don't understand that code, that's fine because it's advanced. So I don't have the code for this one, but I think I had the code for this one also. It's in Microstream training, maybe. Yes, maybe here. Nah, not into this. 2020 advanced 8 hours. We have this empty one. 0.7.2. Employee management system 2022. Yes, in this one it will be there. Exact code. So this is the exact code. I'm sharing the link. I'll explain the code from here. So basically, if you want to find a bookstore with particular books, you can build the bookstore object first with the books that you're finding. Let's say you want book 1 and the string has book 1. So you'll create this object here. Then you'll create example matcher using matching with matcher. You'll pass books here. This is just with matcher. Let me recall matching. Okay. This is the path matcher. Okay, so here with path matcher, what you're saying is match it against books field. So in our bookstore, what all we have? In our bookstore, we have ID, name, books. So we are telling it match it against this books and ignore ID and name field. So it will match it against the books and will ignore ID and name. Why do we need to do this? Because when we build the object of bookstore and we are setting the book's name, which is books 1, which is coming from here, but we are not setting ID and name. So ID and name will be null. So we want to ignore that. So we build this example matcher object, which tells that this example matcher is telling to match against, find the books against this variable, but ignore these two variables while searching. So we build an example matcher, and then using this example matcher, we build the example. So we pass this object, and using this example matcher, we are telling which parameters to compare from the object and which parameters to ignore from this object. Once we build the example, we use the JPA method find all, which takes an example, and it will return us the books, the bookstores with those particular books in it. It's a very advanced code, So you can simply try this out. I've shared the repo link with you in the chat.
On line number 45. So when you run that, so you're going to get every book in there.
Let's do it. Not every book, only the book which we have passed. Let's do it quickly. Okay, let's go to the last. So this is the method. Let's wrap it. Let's say we are trying to get, it's a get request. So get mapping. You can just use this code as a this find particular bookstore. Okay, you can use this as a use this code as a skeleton and write your code once you understand this, because it's a very advanced code. So find particular bookstore which has particular books. Okay, that's the meaning of this. I'm not writing that big name here. Then bookstore CRUD service impl dot what was that big method name that we just wrote? Get bookstore which has particular books. Let's use this big name. Let's do this. So from here, from the URL will pass the books. It will be passed to this method. It will build a bookstore. Now let me quickly show what happens. Main method. If you're building a bookstore like this, so here you see ID and name is coming null. Correct? ID and name is coming null. So in order to avoid comparing against these two fields and only to consider this field, we create this example matcher which says find me the bookstore by matching against this books and by ignoring ID and name field. Otherwise what happens is, if you don't add this, it will try to find the bookstore which has ID 0 and name null and books as these books. But you don't want that. You want all the bookstores with these two books in it, and you don't want to compare against these two parameters. That's why you create example matcher. Then you create example by using your object and example matcher, and then you use the find all method. Let's see this in action. So since we're using temporary data, the database, like the data stored is lost. So what we need to do is we need to go to Swagger and refresh. We need to create the bookstore again. So create bookstore, try it out. Let's say we are creating bookstore with ID 1, name as bookstore 1. Books will be book 1. We've created this object. Let's try to get books. Okay, this new method, get particular bookstore with these books. So book 1, it should return us our bookstore. If we try to find with bookstore 2, there is no books 2, so it's returning empty. So this is how it works. Is everyone clear with this? It was very advanced code, but I still tried to cover in the least time. Any doubts about this code? It's fine if everyone is not able to understand this, but this is very advanced. Like, you don't generally need this. You can write your custom logic also. This is like very advanced way of doing this. All right, let's move to the next one. Okay, I think I've used a wrong PPT here. for some reason, because this one page format and all are not meant to be covered in this training. So just let me go to, this is like 8 hours of training thing which I've covered. I think I just I didn't name the slides properly. So we can ignore this one also, because these are the very advanced one. So next we'll cover is, let's cover directly from the class. Let's cover from here. So we have covered so far create bookstore, get bookstore by ID. Next is count bookstores. So we have a simple method dot count, which will count, and we have wrapped it with the API. So this count bookstore is the API. Since we have one bookstore, we should be able to hit the count bookstore and it should return us the count, and it's returning the count as 1. Similarly, we have get bookstore exist by ID. So it uses this method from this class. Let's see, from this class, bookstore exist by ID. So we are using the JPA method exist by ID. It will find that bookstore, if it's there, it will find by ID. So right now we have bookstore with ID 1. So get bookstore by ID. Let's pass it ID 1. It will return true. If we pass it a non-existing bookstore ID, it returns false. When I passed it 3, it said false. Similarly, we have update bookstore name. Now this is important for you to know. So update bookstore name, this is like for updating a bookstore name of an existing bookstore. Since we have an existing bookstore with ID 1, we want to update the name. So what happens is we take the ID, we take the name, the new name that we would like to set for this bookstore. We first check if that bookstore exists by ID. If that bookstore exists by ID, then we find that bookstore, and after finding the bookstore, we update the name of that bookstore and save it back. So we have to use this save and flush method. Remember, don't use just saves, use save and flush method, because this flush is like commit. Only save method is like put the do that it saves into the persistence context but not into the database. So when you do this save and flush, it will commit your transaction. Otherwise, your transaction will just be in the session which has been opened. And since here we are having multiple database transaction, in this transaction we are getting the bookstore, we are updating and saving, and this is another transaction in which we are saving the updated bookstore. So we need to keep the transaction open throughout this method execution. In few versions of Spring Boot, you need to use @transactional annotation. In few versions of Spring Boot, we don't need this. It automatically keeps the transaction open throughout this method. But here I think I had got some exception which was related to the transaction, so I added this @transaction. Transactional annotation, which keeps the session open, database session opens throughout this method, so that during this line a transaction is open, but transaction is not closed upon getting the result. It keeps the transaction open until the last line of this method is executed. So this annotation is used for keeping the database transaction or the session opens throughout the method execution. So when you have multiple database transaction, this is one database transaction, this is another database transaction, this is another database transaction. When you have this kind of a scenario where you have more than one database transaction in your method, you should keep the transaction open throughout the method execution by using @transactional annotation. Especially if you have this kind of a requirement where you're getting the object, updating and saving back the same object. So if you want to save the retrieved objects, the same object, you need to keep the transaction open. Is this clear to everyone, this part? I'll show the execution, like we'll execute the API, but is it clear like what this code means? Okay, let me show this to you. Update. one more thing which has changed. Yes, one more thing. In the code that I've committed, I've used get by ID. This get by ID will not work. It's deprecated method. Maybe it might work if you're using even more later version than what I'm using. I'm using 3.0.2. If you're using later version, this might work, but in 3.0.2, this was breaking. So today morning, I just changed it with the non-deprecated method, which is find by ID. This was returning optional object, but I know I've already checked that object exists. So I'm directly getting that object and storing here. So just replace this method, don't forget, with this method. So let's update an existing bookstore. We know there is a bookstore with ID 1, and let's name it bookstore. Let's say instead of 1 number, I'm just making it 1, and I've changed it. You know why I've added this check? Why I'm checking if a bookstore first exists and then I'm updating it and saving it? Because there can be a hacker who's trying to exploit my system and trying to insert a non-existing bookstore. Let's say there is a hacker who's trying to insert a non-existing bookstore like this. So this will throw an exception. But if I don't check if a bookstore exists, and if I directly allow, if I don't write this code and if I don't write this code, if I directly have this code, and if I'm directly basically directly saving the bookstore without checking whether it exists or not, in this case, if I'm not checking these things and directly saving it, this update API would also turn into a post API in a way, because it will allow a new bookstore insertion instead of updation. So you need to have a proper logic like this in your enterprise or your office applications to avoid any vulnerabilities. Okay, get bookstore. Let's cover from here. Next, let's go to next one. Next is delete bookstore by ID. So in delete bookstore, again, we check if a bookstore exists. If it exists, we delete it. If it doesn't exist and someone is trying to delete a non-existing bookstore, we throw a runtime exception saying there is no bookstore with the provided ID. Now, if you want to delete all the bookstores that we have, we can use truncate bookstore and delete all method. After delete all, we need to use flush method. I don't know why they have created save and flush method, but they should have also created delete all and flush method. But they have not created such a method, so we need to flush it separately by calling the flush method. Here also, they should create a convenience method like delete all plus flush, delete all and flush, like how we have save and flush, but sadly it's not there. So you need to write 2 lines. And this will delete all the bookstores. So this we have already done. So let's see, delete bookstore by ID. Right now we have only one bookstore, which is with ID 1. We can get rid of it, delete it. We can now again insert one bookstore with ID 1, and we can truncate our database and get rid of it. So truncated. Now if we try to see get bookstores, it will be empty. That's all on JPA. Let's move to Microstream now. Is all the things clear? All the JPA methods? Yes, CC12 flush commits the transaction immediately. Without flush, JPA controls, but I've seen it doesn't really commits also sometimes. So it's better to use flush method. I've seen problems if you don't use the flush method. Okay, is everyone clear with Spring Boot fundamentals so that we can then move to Hibernate? If everyone is clear, you can write clear in the chat and we'll proceed to Hibernate.
Can you take a minute to just talk about the control flow of execution from the beginning of the main class and where it goes? Like, you have multiple packages in your system, right? In your project, like you have entities, you have control, you have services and implementations. So
Sure.
that'll be great.
Okay, so main class is just for starting the application. Later on, whatever is a starting point from the browser, whenever you hit the API, the request from the browser goes to the dispatcher servlet and the dispatcher servlet is part of your Tomcat server. So request from dispatcher servlet is then mapped to the appropriate controller class, and from that controller class it tries to map the request URL. Like from here, we'll try to map this kind of a request. It's a get request and get bookstores. It will try to find this get request and this map matching get bookstores, and it will execute this controller method. And from the controller, the request from the controller is getting the processing from the controller, not request. Request has come till here. Now it's getting processed here. So here in the controller, from controller, the request or the processing gets delegated to the service IMPL class. So this is the service IMPL class which we have auto wired, and we are using it here, get bookstore, get bookstores. Now we are inside the bookstore CRUD service IMPL get bookstores method, and inside our bookstore CRUD service IMPL, from controller we have come to service, and from service we are using the JPA repository find all methods. So how the request comes, it comes from the browser to your controller class. From your controller class it gets delegated to your service class. From service class it gets delegated to your JPA repository, and JPA repository methods does all the magic for us of performing CRUD operation onto our database entities.
Thank you.
All right, perfect. I think now you guys are ready for the Microstream. Let's start Microstream. Before we start with the walkthrough of the project, it's essential that I walk you through some theory to give you the context about what is Microstream. So introduction to Microstream. And one more thing before we begin this, if you really like the training, please do drop a post on LinkedIn tagging Microstream and JavaPro, and you can tag me also. And you can thank JavaPro and Microstream for funding this training for you guys and for the advanced trainings which are coming. Do enroll for advanced training if you've attended this one, because advanced training requires somewhat foundation what you're learning in this fundamental training. So what is Microstream? Before we come to Microstream, let's understand Java. Java is a predestined environment to realize high performance in-memory data processing. So Java is predestined environment for this. And this is why we have Microstream library, because it helps us to have in-memory data processing in Java and very efficiently. We'll see that how. So Java provides a first-class native multi-model data structure, which is nothing but Java object graph, which is our POJO classes, which get saved into the heap memory. And there is no limitation how you can design your graph. So there's no limitation how you want to design your POJO classes. So let's take here. So this is your POJO class, right? There is no limitation. I can have any number of field, any custom classes like full name or anything. So there is no limitation at all. So you can design your object graph freely, adapt it seamlessly to your business requirement, use any Java type, native multi-model data structure. You can use collections. I can also have list of full names or list of address or anything that I want. So use collection, use object references, use circular references, use inheritance. I can also extend this class by any other class, maybe extends person, and it will also inherit its attributes. So no limitation in Java object, or we can call it when the object is saved into the RAM, into the JVM heap memory, it's called as Java graph. So use object reference, circular reference, inheritance, use third-party libraries, only one data model, which is Java classes. Query language to search Java object graph is what? Query language to search your Java object graph is your Java Streams API. You can use streams and you can get a particular book by author, or you can print all the book titles, whatever you like. So you can use Streams API for searching the objects in the graph. And with streams, you can search the objects very efficiently. What about persistence? So this is your application which is generating these objects. These objects are saved in your RAM. So there is, if you want to persist it into a database, what happens is there is this conversion layer. So your objects which are in the binary code, binary data which is in your RAM, gets converted to a format which is specific to the database that you're storing in. That's where you need to add the database, the dependency and the driver name and all, because it needs to know in which database it has to store this object graph in. So it converts this object graph, which is Java native, into database specific. So there is this large data conversion layer which consumes a lot of CPU power, reduces the performance of your application, has expensive latencies, complex architecture, expensive development process, inefficient concept. It requires expensive cluster infrastructure, increases the cost of infrastructure also. Because the database servers, you are charged per hour on AWS or GCP or Azure, whichever you use, and there is a very big cost for storage. Even though reading data from local cache, if you're thinking I can reduce the cost, I can read from local cache, still for storing into local cache like Redis or something, or even local cache, you have to convert the data. You cannot directly store this binary graph into Redis. For Redis also, there is a specific format that gets this binary graph gets converted and stored into that local cache. Still, data conversion layer exists. If you're thinking of NoSQL data structure, even object-oriented databases, graph databases, like if you have used any graph databases like Neo4j, dgraph, all are incompatible with native Java object graph, this native binary code, which is in the JVM. So there is an impedance mismatch. So this is called a system prevalence problem. You have the objects, you cannot directly dump these binaries into your targeted file store, but Microstream enables this. Microstream allows you to take this object graph and directly dump this binary into any targeted data store, be it your cloud S3 bucket or GCS bucket or your local file system. You can dump this binary into database also without having to convert this into any specific format. This is what Microstream does. It allows you to dump the objects directly here. Then you must be thinking, okay, if I directly dump the objects, can I query the objects in the database? Definitely no. If you want to query the objects, you need to load these objects from your database back to your RAM and write the Java code for querying the objects. That is why it says in the start, Java is predestined environment for in-memory storage. Like you store the binaries back and you lazily load whatever you need in your RAM, and then you query using Java Streams API or by writing Java code. So in system prevalence, what are the weaknesses? Snapshot time, snapshot size, long system restore time after restart, not suited for microservices, risk of losing data between snapshot, max database size less than RAM size. So these are the problems in normal system prevalence. If you're thinking, if I can directly dump this, but still it will then ask you to directly load all the binaries back to the RAM, and you should have RAM equivalent to the size of your binaries in the targeted data store, right? So this is the problem in system prevalence, but Microstream solves this because it allows you to lazily load the objects into your RAM from your targeted data store. Risk of losing data between snapshot, big RAM size required, extreme huge traffic, high infrastructure cost, garbage collection issues lead to latencies, class changes, evolutions, Java serialization limitations and issues. So in Java serialization framework, we have this limitation also. We cannot directly, even if you think I can dump the object directly into targeted store by implementing serializable interface, right? You must be thinking this. But you can do that, but the problem is, again, you cannot lazily load. And the next problem with serializable interface in Java is that that if you're having a third-party library class, and if you want to store that third-party library class objects into your targeted data store, you cannot do that because that's a third-party class and it's not implementing serializable interface. So you cannot modify a third-party library class. So that's the limitations that you have, but all these limitations are overcome by Microstream because it allows you to dump any kind of a Java class without implementing serializable interface to your targeted file store. It can be database, it can be block storage, it can be graph storage, it can be any kind of a targeted data store. So Microstream, as you can see, is eliminating all these weaknesses because it's allowing to lazily load. It's allowing to directly like store any kind of data into any kind of targeted data store. It has connector for majority of the big databases, block storages, and everything. So how is the Microstream persistence working? So instead of data conversion layer, we have this Java library, which is part of our application itself. So this Java library is a Microstream is a Java library, which we add to our POM file. We don't need to externally install anything. This is the latest version, which is compatible with the latest version of Spring Boot. This was the version which was compatible with 2.7.6. So I've commented this out because I migrated this application. So you can see that it's a part of application now. So we don't need any expensive data conversion, and we can directly dump the binary to our targeted data store, load back the binary lazily into our RAM and query it. So the major architecture level, we can see conversion is eliminated. Simple architecture, fast time to market, saves a lot of vCPU power because we don't have to do that conversion. Minimizes latency because since we can load it into RAM, and whatever is in the RAM, we can easily query it. In-memory queries executed in microseconds, saves up to 92% cost of infrastructure because now we don't need database. We can even use block storage, which is less expensive than a database server, right? And this is a repository. So where does Microstream runs? It can run wherever Java can run because it's a Java library, as you can see. So since your Java can run on desktop, on your on-prem systems, cloud, container, native image, microservices, Android, any JDK. So wherever your Java can run, this can run because it's a Java library. Use any JVM technology, just one model, which is your Pojo classes. Persisting objects is very easy. So don't refer to this code. I have the updated code here. I'll show you that code. You can like how you can persist the object to your local file system. And this is how it is. You can have multi-threaded IO operation. Like you need multiple channels for that, which I have not done here, but you can refer to the official documentation. There is a property which allows you to add more than one channel. Right now, I think there will be only one channel created by default. So you'll need multiple channels for having multiple multi-threaded IOPS. Loading objects dynamically into RAM, like lazily load objects. And you don't need too much of RAM. You have sufficient RAM because you can lazily load the objects using this kind of lazy classes of Microstream. And if we see another advantage is also like sufficient RAM will be available, no inconvenient object copies, multi-threaded read ops for max performance. RAM is limited, so load single objects or subgraphs on demand. What is subgraph? For if we go back to our application, if this is one graph, this is one subgraph of this big graph. So load the subgraphs. So I have lazy references for these full names and everything so that you lazily load whatever you need so that you can efficiently utilize your RAM memory. Gigantic data throughput and minimizes expensive IO operations. No more classic select, simply call getter method or use streams API. Loaded objects are merged into the RAM directly with the existing objects. All of it is handled by the framework. Coming to memory management, memory is fully managed by JVM. Use lazy references wherever possible. Clear your AC references which are not used anymore. There is a clear method for that, and that calls a garbage collection. In case of garbage collection issues, try this JVM, Azul JVM. Your object graph is your in-memory database. So in JPA, we have this conversion layer. In Microstream, we don't have this conversion layer because it directly dumps the binaries into your any targeted data store. In JVM, we have to convert it into specific as per the database server that we are using. So get started with Microstream. These are the links. I think these links are a little bit outdated, but the first two links, these two links seems correct. So I'll still share it. You can just try that out. That's all about this. Let me show you the practical. I have built one project by reading the official documentation. This is the POM file, latest version, and these are the Microstream dependencies, Microstream storage, embedded Microstream storage, embedded configuration. I've uploaded these projects onto my GitHub. It's all available here. Advanced, fundamental. You can refer to any one of these. Yeah, so it's available here. You can refer from here. I'll share this link in the chat and provide you walkthrough. So we have added the web dependency to get the embedded Tomcat server and for creating the APIs, dev tools for rapid application development, Lombok toward boilerplate code, and the Swagger UI dependency. Then this is our model student. We don't need any fancy JPA annotations like @entity or @ID. All the validation of primary key, we have to write the logic ourselves in Java. Repository, also this is the repository. Before I come to repository, okay, I've written the configuration here only. So this is the repository. Here I've created list of students. Here I've created embedded storage manager storage, and in the constructor of this class, I am taking the location where to store the details from my property file. Using @property, I'm reading the property value of this property in my application.property Microstream store location, and in my user folder, this inside user folder, this folder Microstream Spring CRUD store, it will store all the objects. So if I go to users, Microstream, yeah, so here it's storing all the objects in this format. This is the binary data that is getting dumped. So I'm referring it here, setting to this variable and creating the list here inside this, and this is the boilerplate code for configuring this. So the targeted schema is the students class. So this is the student class, it's the targeted schema, which I'm telling this is the schema of the objects that I want to dump into this location in my local file system. And here I'm just creating array list of students, and this is the boilerplate code. Just write it like this, copy paste it. And this is the documentation from where I got this code. And in the start, we are just writing the targeted storage structure. Once we have done this, this is all we have to do. And for storing all objects, once this is instantiated, we'll use the storage.store method for storing the objects. For storing multiple objects, also it's store method. For storing one object, also is store method. For finding all, we just return this list because this list will be in sync with whatever objects I have here. And for finding by first name, again, we just use this list and we use the stream function, and we filter by first name, compare it against this first name that we have passed, find it, return it, and we get the students with this first name, we get the students with this last name, same, using streams API. If we want to delete, we just clear the array list and we sync the empty array list using the same store all method. Here we had store, so you can use either store or store all, doesn't matter. I'm syncing the empty array list. Okay, the store all, I have only created this method. And inside this I'm using store. Let me see where it is. Store all. So inside the store all, which I'm using for storing all the objects. For deleting all objects, I'm just clearing my array list and passing an empty array list to the store all method again. And this will just delete everything because it will sync my empty array list with the data that I have here, and it will delete everything. So this is the student class. This is the repository interface. No need to see this. This is the main part. This is the boilerplate code of configuration. And this is the controller. Then I've wrapped all the service classes from here. So in Spring Boot, remember the flow goes like this. From browser, request comes to the controller. From controller, request goes to the service class. From service class, request goes to the repository interface. Here we have a class. Okay, so here we have auto-wide the repository interface, which will automatically create object of this class. And here we are using the store all method, storing all the students, add method, which is adding the student, find all. So now you're aware about the flow, I believe, right? we have learned this flow. This is a general way of delegating things in Spring Boot. It's not necessary. You can hard code everything in your controller also, but it's not a good practice. Good practice is to have all the business logic in your service class. So as you can see here, I have added all the business logic. This is the business logic in my service class, and in my controller, I'm just delegating to my service class. So this application has started. It's running on port 8080. I have the Swagger again. So close this, close this, close this, close this. Let's go back here, refresh this. Yeah, I need to change the port. Okay, let's see if I have something from before. I don't think, because I think I've truncated. Yes, I don't have anything right now. So I'll use add. First add one object, student number 1, student name Sam, last name Naru. Save, execute. It is a student added successfully. Find all, and here we can see I'm able to find the student. Find by first name, type Sam. Find by first name. Find by last name, Naru. And I can find by last name. Now if I want to get rid of everything, delete all, truncate, like delete, execute, deleted all the data. Now if I try to do find all, it will not return me anything because I don't have anything. So this is how you can create a Microstream code. Only important thing is you add the dependency, these two dependency, copy paste from here, from this project. You add the location of your local. This is for local, but you can read the documentation and see how to write the code for storing into AWS S3 or GCS, GCP GCS, or onto any targeted database or NoSQL database. We have connectors for everything. And next is next important thing is the boilerplate code that we saw here for configuration. Just these few lines of boilerplate code. This is all you have to do for configuring. Just copy paste this part, change it with your targeted data structure that you want to store it with. So this was my targeted data structure, student. So you can have any kind of complex data structure that you want to store into the into your local file system using Microstream. Perfect. So this is the only framework in the market which is allowing to do this unique thing. There is no other framework which allows you to do this thing. So do use this in your office work, this library, because you can see the power of the library. Even taking snapshot is very easy. You directly copy the content of this file into another file and you change the location over here to point to your new folder, and it will be a snapshot of your data. It's extremely fast. You can see it's like much faster than JPA, very much faster than JPA. If you go to the official doc, the website, no, not this. Go to Microstream. I just want to go to on Google. So very much faster actually compared to JPA. See, is 400 times faster than JPA. You can watch these videos also. All right, that's all for today. I hope you enjoyed this training. For one last time, I'll share my links. You can follow me on LinkedIn. I keep sending lot of training registration links, and you can reach out. You can send me connection request also if you like, and you can sit for my other different trainings that I have. So I train on variety of topics, speed, Spring Boot, Java, AWS, GCP, Kubernetes, Docker, Helm, GitHub, CI/CD, DevOps, Even technical architecture part. Currently, I'm working as a technical architect. So yeah, I do provide all these trainings. And if you need any help, I can provide that. So you can reach out to me for training or for learning or for any problem with like any new technology. And keep learning, keep growing. Thank you everyone for attending today's training.